Hello everyone, welcome to another stream. How are we all doing? How's it going? So I want to start off with a bit of a tiny recap and then what we're doing today. So 2 streams ago we did some we made a compute shader which could render like a circle, rounded axis line bounding box, a regular bounding box. We've got some transparency, some alpha blending, front to back blending. We rendered a glyph and a texture, and then we also got a little profiler working as well. And then last stream, we kind of did a bit of a back step. You know, we stepped back and then stepped to the right, and we made like a drawing API. And then we completely switched to using sign distance fields fully. So we could do some really cool stuff like this, where we could basically define a custom shape, which is comprised of some shape primitives, right? So we've got a circle and an axis line bounding box being joined together, and then they get colored with a different border color and a inner color as well. And then we finish that, and that's one shape that gets drawn. So we've got this really cool API now. So in this stream, what we were doing is we're basically extending the capabilities of this API. We're going to add textures, glyphs, rounded corners of things, all that good stuff. Hey there, Glorissa, how you doing? So yeah, we've got this big checklist here. This is a checklist, and hopefully we tick it all off today, but we might not. The aim is to do all of that. Baldur's Gate finally released me from its grip. Yeah, did watch some VODs. Man, what pressure to see shaders at work. Oh, pleasure. Sorry, I misread that. What pleasure to see. Yeah, they're good, man. I'm really happy. Like, this is part of the project, right? Is like make use of the other projects we did before this. So it's really great. I'm super happy where it's going. And hey, I did a local build of this here. So if we ever need to debug with this application, we can now do it. Because we couldn't do it last time because I updated Arch and it depended on Python, and Python got updated and then it just bugged up. Right, let's go to the game without an engine. This is the project we're on. So where to start, eh? But yeah, how is that game? I've not actually played the because it's coming out on PlayStation. It's on PC, right? Like, I don't really play games on PC. Baldur's Gate. It's coming out PS5 though, isn't it? Yeah, it's coming out eventually, isn't it? Apparently it's like a really good game. But yeah, I've just heard things about it. I've not actually gone to play it. So look at 10 out of 10. Oh. Hey, not so red. Things are going good. Yeah, just been chilling. I go back to work tomorrow, so yeah, I'll have to read plenty of email, you know, that sort of stuff. Tons of catching up to do. I've been off for 5 weeks. But yeah, how's things going with you? Yeah, it's great. Totally captured my heart. Sweet. Yeah, see, games don't really do too much for me anymore. But sometimes it's the odd game that comes on, and it's really good. Graphics shaders. Right, so we'll start by filling in the ones that we've already got here, and we'll take this lovely list here, and we'll open up another buffer, and we'll make a little checklist. Oh, I was hoping this would be a checklist. Ta-da! There's the checklist. Twitch lagging. I think it might just be you. This is the results. Hey, I'm Kept Payne. Thank you, sir. Thank you, sir. I do my best. Right. So when we've like finished with this shader and added all the complication that we're going to be adding, it would be interesting to inspect, like, turn it into AMD's ISA and like see what see some of the stats basically. Like turn it from SpearV into what the driver will turn it into, and just sort of see how many SVGPRs and VGPRs get allocated for the shader, and just sort of analyze it from that perspective, because it's a sort of area where I sort of understand partly, but not fully, and I think it would be a good test to sort of, or a good way for me to learn that sort of stuff, more that more low level side of performance. But yeah, because we've got a lot of switch statements, and I'm sure it's going to basically allocate a ton of registers to use, you see. Right, so we're going to be finishing off this enum. So currently, or this switch statement, currently, this is what we got. So we've got a circle on an ABB with a border. So we want to basically like, so that's the union test. We should move that to like the top left hand side, then do a subtraction test, then do an intersection test. So where is it being called? Here. Here's our nice little API we made last stream. Super happy with it. So I think it's like a temp. Yeah, so it's 1280. So we'll fit like do 3x3s, 3x3 I think, and see if we can. Yeah, so I switched to a 4K display last time, but it kind of has a problem, so I'm sending it back. So I've gone back to my old monitor now. So I'm back on 1080p, tiny 22-inch screen. So yeah, it's okay. So 200 is a little bit big. So should we switch these down to about 100, 150? Then switch that down to about 16. That's half it, something like that. Let's make sure that size has been reduced fine. Did it not compile because you can save this buffer? Okay. This is the aim for today. Right, so it's still a little wide though. Or is it a little wide? Oh yeah, we've seen half it. It was close. Alright, so then we're just going to move that to like the top left. So 100, it's like a 125 width, so we'll give it a little bit of a border, which means we probably want about like, let's just say 150 might be good enough. Maybe not. I guess do 150 in as well. 150, 150. Right, see how that goes. I could probably go a little bit more up, but I think that's good enough. So we're just going to like plaster these over the screen, and like this is going to be a little test basically. And I'm sure, see the current performance is like 0.1 ms, but as we fill this screen, it's going to get far worse. And obviously we are going to be optimizing this shader in the future. But yeah, I guess we'll just make some tests which test every feature, and then we'll get it to be more performant. Yeah. Right, I think that's a good enough size. How many? Well, maybe not. So you could probably fit about 4 across and 4 down, probably. A bit less than 4 down. If I shuffle it up a bit, we'll be able to do better. We had to fit 4 down. Like that. Awesome. So the first thing on the list, I guess, is subtraction. So you get to I think let's make like a little moon or something, right? So let's do another shape. This one is going to be, so when it's 2 circles, right? And you subtract 1 circle from the other circle. So we're just going to put it a little bit more to the right. So if we just say, so if there's a circle, well, the box is the biggest thing, isn't it? So that's a half width. So that gets you to about 100 or 275. So 300 included the margin, I guess. So you probably want to say 300 plus. Yeah, so I guess we'll do it in 300s, and that fits 4 in. Does it? Yeah, it fits 4 in, because it's about 1280, isn't it? Yeah, so we've got 300 of room. So this is a center position for a circle. So let's say that's, so between 300 and 600 is 450. So you probably want to go a little bit to the left because making look like a moon. Well, let's just try 450. And then make the other one like 500. This is the one we're subtracting. Let's do 100.f and see what happens. So that's just a little bit more to the right. Then we're going to use the different op called subtract. That's going to subtract this circle from that circle, right? So essentially it's like circle minus that circle in a way, right? Then we'll do a little bordered color on it, I guess. Not really fast. We could make it a solid color instead. Let's just do a bordered one. So let's just go to the shader code now. So we haven't got the draw type in for. So what it's going to do, right? The way the API works is when you say shape circle, it just literally encodes the circle into an array, and then so we've got 2 circles, and it just gets the 2 distances and puts the distances on a stack in the shader, and then the subtracts will take the 2 distances off the stack, and then it will just produce a single distance. So it subtracts 1 distance from the other. So when we've got in the shader, we go over all the sort of like operations, and it does these sort of sign distance fills and puts it on the stack. And then when you get to like this subtraction here, the way we want it to work, so don't read anything. We've got D1, D2. So that'll just be -1, D2 minus 2. Then you essentially just want to write, so you can take, you probably want to just do take 1. And then you do that take 1. And then you make yourself a distance. So I forgot the subtraction formula. I think it's like a max. I think it's this, right? Max negative D1, D2. I'm pretty sure it's that from memory. Let's go to the SDF Bible and find out. So this person made Shader Toy, and he's like an absolute genius. So he's got 3D and 2D SDFs, like just all the formulas and everything to do like tons of good stuff. Like you can basically like really cheaply do some shapes, but some of them are really expensive. As you can tell, these get quite expensive down here, but some of them are quite fun as well. I've done like the cool S as well. But yeah, so some operations, right? Let's go to the 3D one. That's where more of the ops exist. All right, subtraction. Yeah, max negative D1, D2. Then intersection is just max, yeah. So you'd be able to cut shapes out of other shapes, basically. Then there's the smooth versions, which we'll add in a minute. Cool. So I think that's it, right? So we do take the two distances off. Sorry, get the two latest distances. Take one away. Yeah. That's right. Cool, let's take that for a spin. And we see nothing. No. Why do we see nothing? Should we reduce this one? Should we comment out this one here? Oh, okay. So for some reason, we can only do one shape. For some reason. There's something kind of broken, I guess. So should we follow it through in the debugger and see what happens? Right, so do a core breakpoint. It's the easiest way to get it done, you know. And then we go to GF. Get yourself a GF, everyone. Right, we're in. So I guess I want to analyze like finish GUI.draw. It's 2, okay. Right, so where's the thing we want to know is how does this, like what is the draw command, right? So GUI.draw command word start index, that's 15. And how many words has it got? 13 words. I think that makes sense. So it must be to do with the shader code then. I want to rerun it just a second. And I want to see how it sets it up. So we've got this like implicit start here. So this is going to be like, oh, if I don't know if I need this implicit start because it kind of puts like a branch in there when really it could just be set up. Yeah, I want to make that better. We can get rid of that implicit start. Cool. I don't think we need it. Draw words count 15. Yeah, makes sense. Right, let me just quickly make this better because it's not good. Not the best. Wait, I want to improve my Vim workflow. Why am I like going down a stack of wait a second, let me improve this. Right, so this one. I want to do this one a lot. I want to search for my files that are not open yet. So let me just fill my keys. What would be a good one? Let's do T. Right, let me close my workspace. We'll open it back up again. Right, so I should just be able to say, boom, there we go, UI.c, bam. That's what I want to hear. So in here, there's a bunch of this implicit draw start, and then it ends up just branching. Oh, that's horrible. So this should start at 0 when we start a new frame. Frame initialize. Yeah, when we start a new frame, set that one to 0. And then implicit start. This thing can just get nuked. Just remove it from everything. It's horrible. Much better. Okay, but that wasn't really the actual issue. The actual issue is probably do the shader code, so we'll just check in there. So I've got a new little thing. I can just do that. Did I just break something? Someone asked me for restaurant recommendations, and I accidentally sent them a link to the manual page for VK import memory Win32 handle info KHR structure. I must be so confused right now. Yeah. Yep. I don't know, there's worse things. You can send them the page on like oh, not that one. You can send them the page on really on like the pipeline barrier page or something. Just that one's a confusing one. What does this one do? Import with its memory created on the same physical device. Right. Because I know you can have external buffers from like DX12. Is this what it is? The API used to do it. Looks like it, at least. But maybe not. It's like a handle. It's going to reference in Vulkan to texture such buffer created by other Win32 specific, such as when GDI or oh, right, fair. GFX shaders.c. Right, back in here. So there's a problem that for some reason it was not doing multiple draw commands. Oh, of course. We've still got the breakpoint in here. Break. So this one. Oh my days. I broke the UI thing a bit. I didn't finish it right. This one needs to say and this has something. reset the state. No, leave that one alone. When you finish, you must have words in there, which means a draw has happened. Right, that'll fix it. Oh, come on, what we broke now? Push words. Oh, when I'm saying equal, equal. Let's get rid of that assert, doesn't make any sense anymore. Oh, come on. Can only be equal when something has been drawn. Which one? And draw finish. I don't know, maybe we've got to undo that thing actually, because it has been used as a bit of a check. Can only be called when something has been drawn with draw. I think this font is Liberation Mono, from what I recall. Let's type in the chat. Did it for the recently spent forever debugging the Vulkan code until I realized the bug was in the DS11 code. That's a shame. Right, I guess, alright, let me just undo it. I think we do need it. Right, it'll just be easier. You know what, let's just keep it. Oh, silly me, trying to make things better. For the sake of being better. Right, anyway. So we've got subtract in there as well, and it's not working. Why is that? So the next thing we're going to check is what is this? Because this is what's passed into the shader to say, hey, you've got 2 draw commands. So let's print this little bugger out. Two, just what we want. So then it must mean there's some state that's not being. All right, next one. So next way we can have a look at this. The next way we could just do is just say, hey, I've got a circle without the subtraction. Just see if that fixes it. Doesn't fix it. So it's definitely just to do with the whole shape. Sorry, the state itself. So this distance stack, should this be reset every command? This should be back to 0. That's probably it. Maybe the distance stack is off. Booyah. Progress. Rightio. So rerun this. There's our little moon. I was trying to make a nice moon. It's close, right? That was we up that 75 maybe. So that's subtraction done. Ta-da! So we're doing a circle and then doing another circle a little bit to the right, a bit smaller, and it's subtracting, right? So it's pretty sweet. We're doing the bordered color that we've got. So we still want to do anti-aliasing today. But okay, so that's one off the checklist. So we've got a little to-do file today. Let's do a little tick. We're going to tick it rather than remove it because that way we can feel the progress. There it is. So subtraction is now done. Let's do an intersection one. So intersection will mean like where they overlap, that overlapping part, just show that. So I might just keep the same one, but just call intersection instead. So intersection is going to be, let's just add 300 to the x coordinate. And then in the shaders, we'll go and add that one in. So intersection, you see, so I've kind of done where you can accept like any number of them, and it'll do like a for loop. So you could submit like 3 circles, for instance, and just say, hey, what's the union of all those circles? Yeah, I think it's okay. I don't know if you'll be able to smooth. Yeah, I'm not sure if you'll be able to do that with a smooth though. You might be able to, just gotta work out the maths. But let's just do copy the union one. And to change it to be an intersection, you see. So for a union, it's just the minimum distance, whereas for an intersection, it's the maximum distance between 2 distances. So we take as many distances off a stack that you requested. So it's 2. Yep. And it's just a max instead. Sweet. So let's run that. We didn't get anything show up for some reason. Why is that? So we're going to go an intersection, push the count on as well. 2 words. The exact same as the union. We've moved it a little bit more to the right. That's fine. Should be fine. So let's comment out this one and see if it's one of those sort of like problems with the arrays again, where it only likes 2 shapes for some reason. Well, that's not true. So let's make a subtract again, just to double check to make sure it's still in the right place. For instance, oh no, damn it. There we go. Right, so clearly the thing that is wrong is the intersection part of it. So what that should do is take the 2 distances off the top. Oh, it takes the max, doesn't it? So you use 0, start off with 0. That's the problem. Ta-da! So it takes the max distance. So for some reason, that border is a bit too much. So we put it down to that 8 and see if it fixes it. Like the distance that it's getting back is too much. Is it in the negatives? Well, I'm really confused. Wait, so Yeah, it would be in the negatives. So why? Right, I put -8, it did something different. Maybe it's something to do with my border code. But yeah, you can only work with the intersection operation. So the way the color border code works, so it negates the distance because obviously if you have like, keep this running, on the inside of the circle is a negative distance to the edge, right? The distance is always a distance to the edge of the primitive. So then because it's negative on the inside and positive on the outside, you negate it so it's positive, so it's a number you can work with. So this one here, when you take the maximum, so you've got this shape, and then you've got this shape. Right, so you've got two circles. So we could just union them to make it a little bit clearer. So we union them together. This is what you basically have, right? You have this one and this one. So it's where they overlap. So if you take the maximum of those, you'll be left with a distance you're still be left with a negative distance because you're on the inside of both. I guess the border width is so... Yeah, I think it just might be a bit... So where the two circles overlap and create this one, there's one outer circle and then a smaller circle. See, I don't know what this distance value is here. We could colorize it we could try and colorize it to sort of visualize it a bit. See, what would be really nice, because we have printf in shaders. What would be really cool is if we literally like could hover over with the mouse and just see what that color is on the pixel. Like just have a way to just be like, oh yeah, the mouse, this is the mouse cursor. And then just print out whatever you want where the mouse cursor is. Obviously you have to write it every time, but it will be very useful. So you have to say, oh yeah, this is the distance. And also I'm noticing that the performance is getting really bad now, just with the shapes that we're running with. So yeah, definitely need some form of optimization. That is for sure. Yeah, let's keep going. Well, it's not super bad. It's just like, yeah, it's got like 4 times worse. Isn't that just VSync? Maybe. I don't know, because it was, put it this way, so this is about 0.4 ms. So if I undo these shapes here, it goes down to about 0.1. Yeah, 0.17. So I got like 3 times worse. So yeah. But it's running it per pixel, that's the problem. It's going over all the shapes per pixel, and when we go and write like a tiled, like if we bin them in a tile, it should be much better, hopefully. Fingers crossed, eh? Right, I don't know what's up with that. I kind of want to investigate that distance a bit. So what we could do, I wonder if we can comment that out. So defaults to white. Yep, good. So because it defaults to white, we can do our own little thing in the intersection. I'm going to color the distance. I'm going to put the color in the red channel. A distance in the red channel or something like that. So we just go, oh, what is, so we say, oh, final color. Is that how we work it? Or source color? Right, source color. Source color equal negative distance, right? 0, 0, 1. And then we can multiply it to sort of give it more of a smoothness that we want. So I think it's like really, I don't know actually. Negative on the inside, right? Let's just make sure, let's put 1 in there, see what happens. Right, so the distance might just be really small. So if I say like times 100, don't see anything. Oh my days, it just stays at 0. Ah, there's the problem. The problem is I started this off at 0, and then I'm maxing it. So the distance is only going to be 0 because it's negative numbers. Ah, bugger. Right, so we're on negative infinity. I think we have that constant. Right, that was the problem. Right, I'm glad I didn't sort of skip that and just leave that sort of wrong. There we go. So now we're getting the intersection and we can do the same thing. The border, which is super great. Oh, okay, so we got union, subtraction, intersection. Oh yeah. Oh yeah. So what is the next thing to tick off L list? Intersection. So rounded expand. So remember in the previous thing that we did, so like 2 streams ago, we added this sort of rounded box, and like we did it as a separate sort of like shape, and then we decided to separate shape and color, and then do this crazy sort of like list of SDFs, and you know, make this really complex shader or whatever. But to do this, it is simply like basically make the box smaller and then increase the distance you get back from the box by the radius. Because if you take the way SDFs work, right, is if you have like say if you have a point here, and like you in like it is for a distance from like this thing here or something, right? And you get the distance from this edge. So you have a distance of like that across, you know, it'd be like a scalar value though, it won't be like a vector, right? You have a distance like this or whatever. When you increase that distance by a number, say for instance you increase it by twice as much, what you're basically getting is like a circle, right, that you've increased it by. Best way of explaining it. Yeah, so it basically like rounds things. Yeah, when you increase the distance, you're effectively like rounding it. So yeah, that could have been explained way better. But anyway, so if you shrink the box by the distance, and then you increase it, you increase the final distance result. Sorry, increase it by the radius, decrease it by the radius, the size of the box by the radius that you want, then increase the distance by the radius. Then what you get is rounded corners on the box at least. But you can do that across you can do that on any shape, which we're about to see. I have a favorite movie character and want to make an animation character out of him without any drawing. Any idea? You have a favorite movie character and want to make an animation. I'm not sure what you mean. I'm not sure you mean by animation character. Do you want to animate some like 3D model, or do you want to like animate 2D images? Like what's the thing you want to do exactly? So when we have an operation for rounded expand, it's literally just going to like add to the distance on the distance stack. So we don't do anything other than just like say plus equal radius. So we need to grab a word off the stack, because when we put it yeah, when we added it, when we use this as an amount, we pushed on another word onto the word stack, which was the amount. So we're going to read that back in the shader and then just add that on. So add that distance on, there we go, bam. So we've actually got to go ahead and use this thing now. So let's have a look at this to-do list, then outline. Right, okay. Right, so you should just be able to copy paste. So I want to copy paste the first one and make that one more rounded, because that'd be cool. So I want to like say, okay, plus 300 3 times, put it there. And this time we keep the union, but I then want to like go, oh, can you do one of those sort of rounded expands by about 20 pixels, and we get to see the difference. Hey there, Vegeta, how you doing? Yes, build a 3D model for using in my own game. So I would be careful about using, say 20 pixels ain't enough, but we can animate it, right? That's the thing. We could animate it. Or I could just do a box, actually. Yeah, so be careful about like, you know, obviously, like you can obviously have inspiration, but like copying someone else's work and then putting in a game that you probably want to sell or actually have on the internet will probably be have copyright issues, right? But if you're just doing it for like for fun, I guess there's many ways you can do it. How's it going with Jilla? Hey, Bean. So why am I not seeing a... Aha, because I'm modifying the wrong one. I'm modifying the one... Because distance operand index points to the place where you insert it, but not the one that is on the top of the stack, right? So you take one. And voila, it's been buggered up. Because you want to do a negative. Because negative means inside, so you kind of want to make it bigger that way. Right, that got way too big, clearly. But success. 20 pixels was probably enough. There you go. So you got some rounded box now. But obviously you should reduce that box by the amount you want to smooth it by. But so what we can do is this, right? We can show that in some animation, right? So why don't we do something like this? So we'll call this one something like this would be like round radius or something like that. Something like this. And the circle is going right, like radius increasing. Something like that, yeah. So yeah, naming is definitely hard. But if it's just demo code, you just do something simple. But yeah, I do like descriptive names. Sometimes a bit too much. You know, they get a bit too long. But yeah, if I use something like all the time everywhere, it'll be one letter. Because if you type all the time, it's just, you know, way better. So should we go like down to 0 actually? Greater than maybe 100. So here we get to show this. Well, actually 50 because the smallest side is 50 or something like that. Right, so here's your half width. Right, so we're going to sub S. Right, sub by a scalar, subtract by a scalar, and that's round radius. Voila. And then what we're going to do is we're going to also wait. So start this off at 0, and then we say, oh, there's the rounding radius. Okay, so here's a box. It's gonna go around and not round anymore. So obviously it blinks a bit for some reason. But that's cool. I like it. But yeah, you can see the aliasing is horrible on all this stuff. We should fix it today, hopefully. Yeah, just name it R and R2, you know. Been playing with Jai and doing some fun linear allocation stuff in C. Funny linear allocation stuff in C. Sweet. Nice. So the distance is blinking into negative numbers, or the round radius, should I say. So how do we stop that? I also don't really care, so I'm just gonna leave it. That's pretty sweet. So I want to do the next one now. I want to put it below this one because we're going to be doing the smooth union, smooth subtract, and smooth intersection to show more, you know, and animate it like this as well. Oh, that performance, look at it. Yeah, 0.1. Yeah, this goes a bit fast, doesn't it? Yeah, so you think you want to... Yeah, but then it'll go too slow. Look at it, it's just vibrating. Yeah, computer ain't that fast. That's why I just did 3. But I guess we can like, put it down to 1. I might just do it. There you go. Oh, it still does it sometimes. Oh well. Good enough. So the next one is gonna be, where's the checklist? Outline. So with outline, we could call it stroke. Well, outline is good. So outline is basically like, effectively it is basically just keep the border and discard the inside. That's the way we're rolling with that one. So I guess we'll just use the round radius again. We'll just keep it in that, you know. So for this one, we're just going to say, hey, outline this box for me, please. And then we'll take it down. So we're doing about... So doing 300s across. We've got about 960 going down. So... I want to fit 4 in there. 240. Bam. That's what we want. So we up it by 240. Should be enough room. And then we want to say, can we do this size? And voila. We don't want to do a border color. Well, we could do a border color, that'd be interesting. So we're not seeing any outline. So we need to add it in. So outline in the is, I don't know how you do it actually. It's called onion, or it refers to as onion. Right, absolute of the SDF. And then take the thickness. So it's basically like, right, so you get the thickness. So distance equal take thickness. Let's try that one out. That looks weird. But that's because it's just growing with the... Alright, something fishy's going on. Oh, absolute, that's why. ABS. Let's try that one out, shall we? Oh, there we go. That looks trippy. So, yeah, you basically get to define the thickness. Now, right. Think about what's going on here. I don't know if that's what I expected it to be like. Right, so it's like, it's not outlining it. Huh. Yeah. Right, let's have a bit of a think what this is doing. So we've got about this width and height. We're just animating this outline value. And that is doing absolute take that thickness and then putting it back there. So I was hoping that would be right. So as you increase it, you need to decrease the size. So it's really not an outline, unfortunately. You need to have the similar sort of subtracting thing on the size itself to get it to be like. But then it's sort of rounding it because it ends up being a. For carbonate interiors and giving thickness to perimeters without performing expensive billion operations, see below. Or about distorting the distance field to a monkey's onion and using multiple times to create layers. So all right, let's take a look. So like basically you got that shape at the back and it produces this one here when you call the onion operation twice on it. Obviously this is in 3D. What should we do? Just making it like 0.8 milliseconds now. Be interesting when we fill this page. Right, so let's hard code it to this fixed value and have a bit of a play that way. So if we do like, so if I say like 0, what does it do? Is it nothing? Right, so you kind of get a bit of an outline. Maybe it's a bit of a glitch. So if we say 1, right, it shows up an actual color now. So it does outline it at that point. But then as we sort of like increase it to say, it goes up to about 50, doesn't it? So if we say 20, what it's going to do is it's going to extend it both sides. Right, and then obviously if I take the size away from it, it's like the it's given it rounded on the outside and sort of is keeping the SDF on the inside, right? Yeah, it's keeping the original SDF on the inside, but sort of like getting rid of it in a way. At the same time, right? So the mass works out as take the absolute and then take the thickness. So if you got like a -8, that becomes like +8 and you take the thickness, right? So it only shows up. Right, so the way you can think about it is if you have like, right, let's draw this thing out. So if you have like a box and say on the inside here, this would be -2. Very wobbly -2, but anyway, on the inside that says is -2. You absolutely, it becomes +2, which means it makes it the same as if it was something like this on the outside, right? It makes it exactly the same as that. And then you're saying, hey, negate it by negative thickness, right? So if your thickness is like 3, then it'd be -1, meaning it's inside the shape then, just about. So the thing is like, it was rounding on the outside, but it wasn't rounding on the inside. But I thought, right, because the distance would be different on the outside than the inside, right? Because the distance copies like this, whereas like it'd be like that. But the distance on the outside, the way it happens is -2 will look like this with like a rounded edge. So it behaves differently, right? Yeah, that makes sense. So this one will be boxy on the inside, and when it sort of like absolutes and goes outside, it will sort of be a boxy, right? Whereas if it's on the outside, the distance to the edge actually becomes rounded, right? Cool. So I'm glad we solved that mystery. So can we do like some form of like outline operation, or can we do something like can we make it, because that box that stays like that, I don't know if I like that. I think it would be great if it's just all rounded instead. So, but I don't know if that's possible, because you're taking the absolute. Don't think about it. So yeah, you're right, let's just go back and animate that again. Yes, that is creating an outline for it. Yeah, it is doing that. Yeah, that is fine. Sweet. And then obviously we did that sort of bordered color operation, so it just sort of like ends up coloring it that way. But it could just be flat. Now, is there a way that we can make it all rounded? But I don't think there is a way. Hey there, Ray March, how you doing? Shift the distance. Wait, is this to get the rounded stuff up in? I just said. But shift it by half the line width. Ooh. Ooh. To an earlier question. Is that the one? Yeah. But yeah, I think I want to try and make it all rounded on the inside. Maybe. Because then, I don't know if that's possible. Oh, only on the outside, but not on the inside. Right. Yeah, no, I think I want to keep it. Do half outside, half inside. Because it is doing that. Yeah, I was just, I think originally I was misunderstanding it, but when we drew it out, it made sense. So, but yeah, I want to maybe see if it's possible to get some form of that. But yeah, how's things been? How's the projects going? How's Shame going? So we got the so I don't know if there's a way to, like, you could, like, you can increase this distance. I think like Rain March was saying, and it would inherently round it. So let's have a bit of a play with that and see what we can do. So say if I take the thickness again, but before we absolute it, just see what happens. Just have a bit of a play that way. Right, so that has rounded it. Can you see? It's giving it a round. But obviously it's made it bigger. So then let's take the times 2. I don't know what it's going to do. I think it's still going to be wrong. Right, it's just bugging it up. Maybe not. Nope. All wrong. So yeah, so I guess another bit of a problem is that yeah, so it just repeats the inside SDF a bit. So it's like, so maybe the user should just do a round operation on this. Say if they want to round it by 20 pixels or whatever, you know. But then it doesn't work as you go in. Damn it. And I got scale with the, so maybe take thicknesses. I wonder how correct that is. We should layer another one on top of it so we can actually see. Let's do it without the outline, and let's just do a solid color of red. Right, let's make it angry. Angry red. Wait, how thick are we going? Wait a minute. We kind of want it bordered. With an invisible, completely transparent inner with about 4 pixel thickness. Well, inner, outer, I think. I think I bugged that one up. Yep, just gonna make it red again. Make things red again. That's red there. Voila, that's too many pixels though. Why? I say, oh, I meant 4. Well, we'll just do 2 pixels. Probably enough. Right, here we go. So we should be seeing this on top. Wait, it's front to back. So higher up is more in front. Right, there we go. Alright, so good to see. Hey there, Emma Dema. Welcome. For rounding on the inside and outside, I'll scale the box down first, then offset the onion. Right. I see. Yeah, so it should all be possible with these basic ops, I guess. Yeah. Project is going good. I figured out something that will let me delete metric ton of code. Excellent. Which is always great. Sadly, a bit behind schedule because of work and very dumb. Lots of office politics. Will quite soon. But yeah, I did that with my compiler where you sort of like wrote it in a very complicated way first, and then you like have a moment where you're like, right, this could be done far better, and you can just delete all the code that you've just written. Which isn't sad. It's pretty great. I enjoy it. I think it's good when you find that. But yeah, have you got a new job in the horizon? But yeah, hope that gets sorted out. What's going on actually? I don't quite understand what you're doing right now. So we're doing some UI rendering, using signed distance fields. So we're trying to make a super flexible renderer using nothing but compute shaders. We're currently doing UI right now. So we should be able to make any shape graphics that we want, and give them colors, give them texture them, all sorts of goodness. with the power of sign distance fields. So if you don't know what a sign distance field is, basically it's a distance from distance from an edge. You can give them a search. There's crazy stuff people do with them in 3D. We're just using the 2D ones for now. So here's the most basic one. Sign distance of a circle. So if you basically the formula is given a point, also known as a pixel, what is the distance from the edge? And the distance is basically inherently like a circle all the time, right? So what is the closest distance? Obviously it's this edge here, and it's negative on the inside, positive on the outside, meaning you can basically, every pixel that you sample, you can be like, is this inside or outside? If it's positive, it's outside. If it's negative, it's inside, and then you can color it a certain color. But furthermore, you also have a distance value, which means you can still do stuff. Like we basically have a way of coloring a border in based on the distance from the edge. There's tons of good stuff you can do with it. You can do anti-aliased edges as well with that distance value. All sorts of goodness. Then the issue is sometimes it can get a little bit expensive in the shader because sometimes the maths operations are quite expensive depending on the shape. But yeah, sign distance fields are the best. So we're just trying to do we're trying to just add all the flexibility in, make it fast, and then use that as have a nice API at the ready when we do some UI stuff. No, I've not played with Factorio. Not seen it. I've heard about it though. Fair play very much. Have you got a job where you do Rust in your main job? Maybe you should come around for a Rust job. Yeah, well, if you suck at developing graphics, you just gotta do some more. I wasn't good at it. I just keep trying stuff. There's so many, graphics kind of there's a lot of stuff you can do in it, lots of areas about graphics, but you just keep trying to get better. It's the same with every field. Are you using C API from GUI or are you working with C? No, C, just C. We don't use ImGUI. We don't use Dear ImGUI, right? It's the problem with the name. It's such a bad name. What's the name of it? But anyway, we are going to be doing an immediate mode UI, our own one, basically. But it's going to be more simple and designed specifically for our game. We're not going to use DRMG. Alright, so what do I want to achieve with this sort of outline thing? So that was me just so this is our little red box to sort of say, hey, how's this thing behaving? So we can sort of see it. And then so this is where we Huh? Right, so we run that, it's just gonna, right, so it just expands outwards. And then if you do the subtract on the inside, like this. So it's an outline that grows outwards, and then oh, it's rounded it. What the hell have I done? Oh, no. I messed up the outline shader on the inside, didn't I? Right. Oh, that's why. Right, so that makes it go inside. Wait, so let me just see what I just stumbled across for a second. And let's see how that compares. So it has rounded it like I kind of hoped it would be round. Well, no, it doesn't. Alright, so just get rid of that. And then we want to like get rid of the subtract here on the box itself. Right. Yeah, so that is doing what we expect. So the red is where the shape is originally, and then we do this sort of like outline, as we call it, but it's called onion on the website we've been taking it from. But yeah, it sort of just does this. I think that's okay. Like, it's only not rounded on the inside because the shape that we're passing in is not rounded. But if we were to round it, it would be rounded. So if we were to say, do this rounded expand, let's just chuck a roundedness of like on the shape itself. Let's do a double on the outline, I think. Maybe, no. Oh yeah. But we're meant to subtract the shape size because, and then that ought to not do it. No. Right. Yeah, I think that's good enough. Oh, we got it. Is it possible to use SDFs to create an outline around an object that's not a constant width, where it tapers instead? So you're just getting a distance back from the edge, right? So you don't know where you are on the edge, right? You're just getting assigned a distance from the edge. So imagine this is -2, this inner box from the actual edge here. Like this is the same value as this one over here. And the same one as this one here. Same one as this one here. So the only thing you can do is like, you can manipulate the value differently, providing that the distance is different. So you could basically square it or something and make it behave a bit differently. You could square root it, maybe behave differently, but you can't, but it's only on the distance itself. So as an example, you can like square it. I don't know how this will behave. And it looks different. But yeah, it's only a distance value changing. But yeah, you can do a lot with a distance, right? We're outlining the final shape. So we've got a final shape here, and just with the distance alone, we're able to put a border around the whole thing. You can also do a gradient or a smooth version of that. Right. Yeah. Alright, I got that back. That's good. Right, so can I like shuffle that around? Maybe. Yeah, let's just do divide by 2 to make it just a bit too big for my liking. And maybe let's like change that. So it doesn't have to be bordered, but I don't know, let's just say like 4 pixels. There are ways to use sine/cosine to handle horizontal distance differently from vertical distance. Yeah, but it's just a distance, right? Which just makes it like, which means it could come from any orientation, right? Because you have like a point, and when you get given a distance, it can come from like anywhere around that point. So you can't tell the orientation. Basically, you know. You can change the outline with another distance field. If you do that before you cut off, you get wobbly outlines, etc. Ooh. You can change the outline with another distance field. Oh, with like a sign. Oh, isn't that lovely? So you can apply a sign to it and you get wobbly. Look at Raymarch go. So what Raymarch is saying is like you could add, like imagine if we added, like, so if we just say like distance. So imagine if we had like another op and called it op sign or something like that. You could say like, wait, what's the thing that we can take in which will sort of change over time? We've got the coordinate. So we could probably do coord.x plus coord.y. Wait, is that float? It's float, good. Maybe not. That looks cool though. What the hell have I just made? What the hell have I just made? What is going on? That looks sweet. Wait, I'm just making it equal. I didn't do plus equal. That's why. Ugh. Yeah, it's a bit too much there. But we could do some cool stuff. Let's make it a bit like, let's increase that. And then you said you need to like scale it down. Maybe. What's the distance? It's like a 1 pixel. Is scaling up going to be too much? Oh, right, you're talking about scaling the input. Right, yeah, so we can scale this up by about, I don't know, 5 pixels. And then you want to scale down the, this by about 0.1 probably. Ugh, that looks ugly. But yeah, bit too much. So say 2.5. So we could just do it on the x-axis, maybe. Yeah, you see the sine wave. But yeah, because that makes it look sort of diagonally. But yeah, there's stuff you can do. We could be creative. But yeah, that's cool. Right, you give me ideas now. But yeah, so I guess that's another benefit of this game van engine. We can add more ops or whatever. We can style it. Try fract, right? Because that'll get you. Ooh. Wait, what are you fracting? This thing. Oh, instead of sine. I don't know if my fract is working. It should be. Should be. Let's times it by 100. Yes, pixel space. Oh, of course it will. Hmm. Let's try that out. You're just getting a bunch of like, you're getting like a little rectangles sometimes. It's weird. But yeah. Cool. Maths. Rightio. Right, so that was a nice little play around. I'm glad we did that. But let's get back to the business. So the next ones we want to add, so we can take that one off now. We're going to add these three again, but down here, these can be the smooth unions and smooth subtract, smooth intersection. We'll take a look at it and see if we can. So the thing is about the union op is we have the ability to like union more than one thing together because it's just a minimum distance, right? And that's how union shapes together. Whereas the formula for smooth distance is a little smooth union, sorry, is more complicated. So D1, D2. Right, based on some factor. So you're getting like a difference between the distances and smoothing it basically. Yeah, I'm not sure how you do that with more than one shape, to be fair. So maybe we just won't do that. We did it mainly with the union. Because I thought you might want to join multiple shapes, so just make it easier. But the smooth one, I guess. What happens if you're gonna smooth multiple ones together? Right. You can do it with two shapes, then that shape, and the third shape. You can chain the calls. Right. So the smooth union, yeah, so I can do the loop then. Because that's all I've done is just put it in a for loop. Yeah, because you would just smooth union multiple shapes. Yeah, so let's put it in a loop again. Yeah, that'll work. Thank you so much there, Daphne. Lunara, thank you so much. Right, so we're going to be adding these three again. But yep. So increase that by 240, the y by 240. So part of me thinks though, I don't know. Do I want to do something more smooth union? Wait, we didn't check stuff to the checklist. Right, we need to add smooth versions. So there's a count and then how much. I want to smooth it. To say amount. So I want to take these ones in. So it'll be like the intersection and all of. It'll be like the non-smooth ones, but we just put in an extra. We push an extra word into the shader. So just put those in. So all we do is we basically just have like a bunch of words, like a 32-bit integer words. So we can just, the first word is always the op, right? The operation. And then any of the words that come after it, that they belong to the operation. So you just have to match them from CPU side to GPU side. So there's a count that goes in, but there's also an amount that goes in as well now. Cool. It's the subtraction. So the subtraction, there wasn't. You can. Wait, why can you subtract multiple things? Yeah, we could have chained it, right? Because you could say, hey, I got this shape, and then just say, you can say subtract off these areas. Yeah. Why didn't we do that? Right, let's add that into the subtract then. Yeah, I jump between Linux and Windows. So I go onto Windows when we do any platformy stuff. Basically, interesting. I'm experimenting with SDFs for outlines. Currently using the Laplacian kernel to calculate the depth differences for the outlines. The visual result is great, but I want to see if I can change the width of the outlines, change the size of this kernel. Precise. To protect performance, but there was. Yeah, I'm not sure what the Laplacian kernel is. Oh, right, yeah, they technically don't make a proper distance, yeah. I see. I see. Right. Yeah, there's also different ways of doing it. Like this is like infinity norm, isn't it? But there's also like L2 norm. Right. So you go to like articles, there's wait. Oh no, sorry, that's L infinity norm. Oh, so L2 norm. Whereas L infinity norm is like it's more like rectangular. So a box is really cheap in L2 norm space because it's just the max of the extent, something like that. No, it's the max of. Yeah, it's the max. Whereas a circle is more expensive, but the shape is different, right? It's more of a box distance rather than a circular distance. So some shapes become really cheap, whereas others are not. Yeah. Let's have a look. Oh yeah, I remember you made this one. Yeah, we were speaking about the whole you was describing this to me before. Yeah. This was a good graphic you made. It was one of my Raymart shaders, wasn't it? See, I'm glad Raymart knows these things. You know, if not, his name wouldn't be very descriptive of his of his uh of his domain. Um, right. So we're changing that sort of like yeah. So we were going to push a count into here, which means then in the shader for subtract, we kind of want to make it more like union. So let's have a bit of a think. So we extract the count out, increment the word index, so we've read the word. So when it talks about distance, so you basically want to read the first distance off. And then, right, it might work a bit differently, which is fine. So you read the first distance off, which means so you read the first distance off, and then you start off on 1. And then you read the next distance off, then that one will be a max. But really the rest should probably work that way anyway, because then like hey Akraz. Yeah, the stack API is staying here. Yeah, it's a good API. I like it. Very good. Distance equal. So you read D. And it'd be negative distance D. Wait, you gotta get this right. Yeah, so we might actually have to change the subtract so we can actually see it in place, which means I want to change the ones above so there's actually 3 shapes involved, and then we can actually ensure this works fine. So I think it's that, because you're subtracting D2 from D1. So when you chain them, it should just work like that. That would be stellar. So we'll see if it works the same. Oh, of course. We got stuff here. Oh, got a 2 there, please. Right, so we've just copied the ones from above, basically. Oh, my days. Let's if 0 these guys, cannot call them yet. Right, so they still work the same, these ones up here. Why didn't these ones... these should work the same up here, right? They're just union, subtraction, intersection. So these are the smooth ones. Did I change those in the end? Subtract. Wait, what do we do? Oh, we didn't increase both the shapes by 240. So obviously the other shape that wasn't in the same space. There we go. So now they're down here. Sweet. So what I really want to do is add another shape to these. So we're going to change this one to have like 1 ball above, 1 ball below. And then this one, we'll subtract 1 from underneath as well. And then this one we'll just have another ball to the left-hand side. So let's just quickly do that. It shouldn't be too hard. So this one here gets the ball. So we put one ball. What we're doing again? Yeah, so make it smaller to about 50. And then we can up this one. We'll take 50 away. Oh, what did I just write? So 50 decrease, 50 ink. Maybe that's too much. Let's see how that works. Right. This is saying that we basically like something's buggered up in our API. So we didn't increase this to 3. So when we called finish, was it? When we called color, it was like, hey, you've not got one distance left on the stack. You've got like 2 distances. You've joined these 2 shapes together, and you've left that distance on the distance stack, meaning there's 2 distances. So we need to say there's 3. So that combines these 3 into 1 distance, and that'll fix the problem. Right, kind of not what I wanted. Let's move them in a bit and make them a bit bigger. So let's make this 100, make this 150, make this 75. And then we can do some smooth unions. Yeah, like that. I do like the moon, but the moon has to go for the sake of testing, which is fine. So basically I want to kind of repeat this guy, but then increase the Y by 50. And then reduce this to probably something, maybe it can go to 50 as well. Something like that. Oh shoot, what do? We didn't increase the number again. So there's subtract, hopefully that'll work. Oh, we buggered that one up as well. Right, because the subtract code didn't have this little thing where it modified the distance stack, basically. To say, hey, we've reduced the distances by count -1. Yeah, so basically, so what we're doing, I'll describe it. So in our, where's the bugger? This one. All right, I'll go over the API. Yeah. So that's the thing. We check its CPU side, the Lunar. Yeah, we check its CPU side, so there's no problems. Yeah. So effectively, what we have is we have 2 arrays. We have an array of draw commands, as we call them, and a draw command is like when we say finish. That's one command. Finish, finish. So a command is like it is comprised of multiple shapes, and then you can have operations as well that happen. So every time we do a shape, it pushes on a distance to the stack, right? So this pushes on a distance, that pushes on distance, pushes on another distance. Then we say op union, and that will take the 3 off the stack, and it will then union it. That will then obviously do the union operation and then produce 1 distance out at the end. So it takes 3 off, pushes 1 on. And then we have this sort of coloring thing, and color can only work when there is 1 distance on the stack. So it's basically saying it's the end. So we've got different ways of coloring. There's a bordered color, we've got solid color. We're going to be adding textured color as well, so just texture. And when you have multiple colors, it just multiplies them together. So you can basically do the whole, sort of like texturing and then multiplying it with a color and tinting it or something like that. Is it a dynamic array? No. So we basically like in the UI subsystem, there's 2 arrays. One array is the commands, and another array is words, right? And the words, basically, the way the words work is, yeah, so it is a dynamic array, I guess. Two dynamic arrays, right? They're growable arrays, but they're fixed allocated. That's what I meant to say, sorry. So basically, whenever you say do a shape, you push on the words, and you go, right, we've got a circle here, and then you push on its operands just after it in memory. So you go, here's the center position, here's the radius, and that's all you need to compute that distance. And then, what does shapehand do? Nothing much, just checking code. And then when you do a finish, it will go like, right, get that range of words, like at the start index and the count, and that's a command, and it puts it on another array. So all the shader does, so it's a bit unoptimized at the moment, but we're going to make it better. We're going to do a tile-based, we're going to bin these per tile. We'll do 8 by 8. So we have a compute shader that runs. Right, it's gone a bit weird. So we have a compute shader that runs per pixel, 8 by 8 at the moment, but we'll make it run per tile. We'll do a pre-pass and bin it per tile. But we run it per pixel. It goes over every draw command, right? That's the slow bit, and it does front to back, or and we do front to back alpha blending. And you go over every draw command, and then obviously go over every single word for that draw command, and that has multiple shapes, and we do that whole distance stack thing. So we have a stack here, we have a sort of capacity that is known CPU and GPU side. If we go over this on the CPU, we'll know and it will crash. It won't crash on the GPU. So we just basically have this little stack of distances, and we have this distance operand that's sort of like, when we do a circle, we just push the distance on the end of the stack, and then we obviously, when we do this sort of like union, we take the last 3 distances and min them, and then we put it on the end of this, right? We take away the, so that's basically the rundown of how this thing works. If you have any more questions, feel free, but I think that was a good rundown. There's like an upper bound or something and a stack pointer-ish thing. Yes, that's right. This is HCC code, right? Yeah. So this is my compute shader written in C using my custom C compiler. So there's one or two little extensions, but it's mostly just C code. No, this is Vim. What does the front and back alpha blending mean? No, so you can so if you can alpha blend back to front and front to back. Front to back is the best because but most things can't, like front to back is the best because then it means that you can early out at alpha of 1. So we've kind of got an optimization already where if when you alpha blend it front to back, you can early out when it's fully opaque. So it saves you going over any more draw commands. So that's already an optimization. Like, if we take this away, it'll run even slower. If you had multiple things in the same pixel, but which we don't. So, but we used to in the previous thing, so it works. I promise. I swear. But yeah. Right. So we're trying out the subtract thingy, weren't we? Right, so that one didn't work clearly. Can you see it put another shape in there? So it's like the subtract didn't work. So I didn't subtract the second shape. So I'm glad we tested it, right? I went to test it. So yeah, it was used once, so it works, and it still compiles, so see, part of me's thinking, like, should we bother setting that to infinity? I think, right, I want to do it this way now. I've had a change of heart. because there's always at least 2. And then you can say distance equals min distance, and probably end that there. Sweet. So I think we can try that one out. And I want to do that again. Could we call it D1, D2? Oh, all right. Let's just make sure the union and intersection haven't broke. Right, they're still the same, which is good. Right, so this one's not what we want. Multiple subtraction here. And on the second iteration, it was like, no. Well, yeah, so the second iteration, it was like, no. So, why? So, count is 3. Let's pop you back to here. 3, yeah. So, let's just double check quick that we actually got 3. So, subtract. We pushed on count of 3. Here's a little word. So jobs are good and right. No, something is wrong. So max of, I think that's the way it works. So trust me, bro. Trust me, bro. So we get like a subtraction. Yeah, so you negate D1 and it's the max of that. So if you go around again, like, and then pick up another one, it sort of like just added it. Oh wait, I didn't start that off on 1. That's fine, but this one goes 1, 1. Good. Anyway, so maybe we have to put it into a different. Hey there, Sully. How you doing? Can you dynamically decide not to push things to the stack if they're far enough outside of the bounding box? Yeah, so we're going to be tiling it. So that's already going to bin stuff per. But yeah, I guess. Yeah, it's a compute shader. It still should work, right? It's going per pixel. So if you have the bounding box. Yeah, so we don't have the bounding box yet, but we will have a bounding box. But I guess that's another optimization, right? If the pixel is not inside the bounding box of the thing, then we can skip running the distance value, I guess. Yeah, that's a good optimization actually that we can do. I might write that down. Right, cry face. So you get the max of those 2, then it comes back around again, gets another guy, then it flips that distance. So again. Right, so I think the issue is like the fact that this distance keeps getting flipped, maybe. So perhaps we should just negate that one first. You know, I'm putting that on another line because that's so easy to see as a. So maybe the idea is like you're just meant to do that. Right, don't work. Just have a think how. Right, so if we were to sort of like put this. Right, you get this result back, and you put that result back into here. Maybe you can't chain these together because you're meant to say that too. But it should be, right? That should be how it works. Would putting the shapes on the stack in a different order fix this? Putting the shapes on the stack in a different order fix it. Interesting. Wait, could that be the issue? No, it's not, is it? But I see what you're saying. So what happens if you just turn it the other way? Because the way I read this is like, imagine you just join them and you put takeaways there, right? So you're saying like but it's as if it's like doing like a union on it in a way. It's weird, but let me just swap them around. So that's like, yeah, left that one there now. So it's like, it's as if like the last one to move the first one to the end. I don't know what happened there. Weird. Right, so pick up the count, then you say get the original distance. Or get the oh, we're processing the stack the wrong way. You getting oh my days. Yeah, we are, aren't we? So I should, if I invert it the other way. Oh. Right. So let's run it the other way around. I see what you're saying now. That was, but then I think we want to then put like the distance, something like that. Gotcha. There you go. Right, thank you. That led me to the right. Right, we got it. We got it now. Okay, so we increase the size of those shapes, and then we got to sort out that. So we'll undo this, increase the size of these shapes. Yeah, because the issue is we was treating this last distance as the first distance. It's just the wrong way around. Right. So what we want to do then is do a reverse one. So what we want to do instead is say I guess so we could just say minus counting 1 at the end. And then this one is just going to say, right, my operand index, or like, what's 0 then? I think maybe do like a plus index. Maybe actually this just becomes a +1 at the end. And then we take count away from it. And then you say just that one. Remove that. And voila, there we go. Rightio. Fantastic. Do I want to do 75 or is that a bit too much? We'll do a 60. Right, that was good. Excellent. So I'm glad we sorted that one out. So now we're back onto the smooth ones now. So we started adding the smooth So let's copy and paste these ones again. We'll move down to here. I don't know if I finished the implementation code, so we'll get this sorted out. So we're just going to increase the Y by 240 and bring them down a row. Just the same example, basically. That's good enough. Then we do smooth union. Smooth subtract and smooth intersection. So these guys need, let's change this around the other way. So I think I want to do a count first, and then we do a, so we say U32 count, count, and count. Then we go to the implementation of this, just somewhere like here. So it's a little bit wrong, but smooth, smooth, and smooth. Right, so we'll upload this, or we'll poke it into the buffer correctly, right? So we'll, so this is copied from the union code. We want to add the new one, which is smooth union. See, I'm not sure how good having all these cases is, but I guess we'll see. You put the count and the smooth amount on. Good. So we want to copy the subtraction. Put that one in there. Copy the intersection. Put that one there. Then we want to add the amounts in and change them to like a smooth, subtract, and smooth section. There we go. Fantastic. So that is the CPU side of the code. Now we've got to hop into the shader code and add smooth versions of these in. So they come after the other ones, so we'll just put them in the same sorts of places. So the code mostly stays the same with these sort of loops. The only difference is the for loop inside the for loop itself. There's a lot of switch statements. I don't know how good this is. The power of features. So you should be able to use something like this basically. It's got to convert it to C code. So D1, D2. D1 is distance, and then D2 is D. Let's just make this better. Well, I gotta put .fs because we don't support doubles. I might have missed it, but what does this stack allow? Can't it be done with a Varderic function or regular function? So the stack allows you to, so the distance stack is just a way to temporarily put, like, it's basically a virtual machine, right? With like instructions. That's basically it. So you can like define like you're defining a bunch of so like these could be anything, and the idea with this sort of stack, evaluate multiple times. I'm not sure what you mean. So the point is like you're calculating a distance, storing it on the stack, calculating another distance, store it on the stack. Then you're manipulating the stack, basically. So what's the motivation? Uh, yeah, we have the VODs. Yeah, this put on the stack thing. Well, this thing, this distance operand stack, that's what you're saying. What's the... Let's answer the VOD question. Yeah, the VODs are all up on here. You can go and check them out there. It's something to do beyond, not for you to be motivated to build this. Well, the whole point... Oh, okay, so what's the whole point of, like... Alright. So the whole point is, like, I want to make a very sort of flexible... Like, why am I doing this whole thing? Right, I see the question now. So, I want to make, like, a flexible way to do UI rendering with, like we could just do simple, like, shapes or whatever. But the idea is I want to have, like, a sort of a general API that I can just write, that we can just, make like shapes out of a bunch of, like, primitive shapes and sort of do some sort of game UI. And hopefully it'll be fast enough. So right now we're about 1 ms doing all this stuff, but we're going to optimize it, obviously. Where you can basically just, imagine, like, having, like, something where you just subtract some shapes and it looks like it's just been eaten bites out of it or something. Or you just, like, it's just having, like, scalable graphics that you can sort of play with in a sort of playful game-like way, basically. So that's the sort of idea with it. And you can do like Boolean operations, and like anti-aliasing as well comes for free. Hopefully, we'll see if we can get it for basically free. We haven't done it yet. We had it done previously, but I'm hoping with this sort of, like, complicated way we've done it, we can sort of get a free-ish version. But yeah, basically, it's basically a way, because the way I imagine it, right, is, like, it shouldn't be too hard to build a way to interactively build these things and add some variables. You have some UI that's sort of like, we can drag some shapes in, attach some variables to some shapes, synchronize some. Maybe, I'm not sure about animation always is where it gets the code starts sort of explode a bit, but I'm thinking, like, just at least to assemble shapes, and you can get it to code gen, right? Maybe the animation can be done with some variables and just a simple, like, timeline to sort of, like, drag the time. But like, in the future, when I want to do all that stuff, I think, like, we can throw something like that together, and it'll just be so interactive and nice, and I won't have to write code and think about it, right? So yeah. But what do you use the stack for? Can't it be done with functions like union? Yeah, but yeah, if you write that in the shader, but we're not writing it in the shader, we're writing it in the... Yeah, but if you write it like that, right, you have to write that in the shader. We don't... So we define it CPU side, and how it gets executed is like a virtual machine, right, on the GPU. It's like, it just gets an array of instructions, and the stack is how you keep them in registers or memory, right? That's all it is. It's not because, like it would be great if we can write it like the way you've suggested it, but it just has to be, like, you'd have to write that in the shader itself. That be achieved. Whereas this is more of like I'm doing a UI rendering API, and if we want to do some custom drawing, the way you do it is by making this sort of like instructions for the VM to sort of like render it basically. Like, yeah. So this is CPU side. But isn't it the perfect use case for HCC? You can execute it once on the CPU and once on the GPU, returns the same shapes. To spin out ideas. Yeah, so the problem is with that is like so you have to compile it into the shader, and the inputs for those shapes have to come in somehow. So however you define those, like you basically have to put the shader language is basically C. It is C. It's a C compiler. Like we've got a C compiler. It's like, I guess people say like it's not technically C, but then like neither's Clang, right? Neither's GCC, neither's MSVC. They're all not technically C. So C compiler doesn't actually exist in that sense. But yeah, see the way you're suggesting it, already, March, your idea is a more optimized version. Like if you were to sort of need it to be super optimized, you would instead probably go with like functions that have the sort of SDF code all in one consecutive sort of like or just all together, and then computes a distance. And you probably need some form of switch statement, but to sort of go switch between the different sort of like shapes that you want to make, right? But we were doing that approach before. We was saying like command type ABB or command type ABB rounded, and we did this, right? And then we had like a texture one, which is just a box. But then the thing is, it wasn't controllable from the CPU side. It wasn't very powerful, right? So that's why we went the stack approach, so it could be completely configured by the CPU, basically. But yeah, I'm not sure if you're suggesting something else, but yeah, I think that's basically what we went to and from. So then distance would just be equal to the result of that, hopefully. Right, so should we just try the smooth union first and just see what we get? Well, I think that will bugger up, actually. Wait a minute. Amount. That's an F32 there, please. Right, put that there. Move this one up here. Boom. So we want to do like... where's the bugger? So you extract out the distance. There we go. K was the amount, basically. Right, so we should just be able... So I think we're going to have like... So what's single like rounding radius? We'll just chuck that on there and have... Hopefully that'll be good enough. Clamp. Mix is lerp. Oh yeah. Why is that so? Okay, that's definitely wrong. So we'll investigate that. But something's happening. This topic is very close to why I built Shame, so that like. So I like to hear the design decisions with the CPGP code sharing stuff. So I'm aware of different ideas. Right. Your egg is hatching. Yeah. What is it? Um. But yeah, because the issue is like if you define like code that runs per pixel across every thread, like you basically need you need to be running the exact same code across every thread, or you need a switch statement that decides. Um, or you need a specific shader that runs the same code. Always the same. Yeah, yeah. It's yeah, it's really a different problem. But yeah, like yeah, you should very much. That'd be good. Yeah, if you stream that sometime, send me a message and I'll tune in. Yeah. Um. Yeah. So one thing to take away is from this is even so right now every pixel is running the same. Like it's every pixel runs the same case statement always, and even when we optimize it, it will do that. Um. So that's also it. Oh yeah, we need a different shader for each. Exactly. Yeah. Yes. Yeah. So yeah. Basically built around closure captures with functional programming. Yeah, but you will end up code genning, right? Different shaders, right? Like there's no. I don't think there's any other way of doing it. Right, you're basically making permutations, right? Um. Okay, so oh no, we don't want to make sure this is right. So I think we want to. Oh, D2 D1. Again, it's the same problem, isn't it? As the. Hmm. Um. So let's switch back to using just standard union and just make sure, the shape is actually correct, because that's kind of the first thing. Right, the shape was, it was wrong. So, of course, the other thing is going to be wrong because I didn't increment this one by 240 and so it wasn't in the right position. Voila, there we go, smooth union. Look at that goodness. Oh, it's like a little eye at the end, isn't it? At the end, that's cool. I basically built one big distance function for each shader. Wait, sorry. I basically generate one big distance function for the shader. Memory and speed. You can fast forward by having more smaller shaders in memory. Yeah, but it also depends, right? It entirely depends on the algorithm, right? Um, like, it really depends on the algorithm. Like, this algorithm depends on the fact that, like, nothing else is writing to the same pixel as you at the same time. And also, like, how many and how are you solving this sort of Z ordering problem? How are you like, 'cause if you launch many shaders, say if you did a shader per shape, right? And obviously I'm using compute shaders here, so that'd be really bad. Um, yeah, shader per shape. Like you got to figure out how you're gonna Z order them, and do you put barriers in between all of them, and then you're like basically not using all of your compute units, right? So yeah, there's all sorts of like things to think about. There's tons of little trade-off. Whereas if you use like the pixel shader though, you will get it. It automatically like sorts it into basically compute shaders on the GPU hardware, right? For you, and then you just got to solve the sorting problem in the pixel shader. All right, smooth this bugger. Let's do the next one. Right, so it's basically the same, but there's a negative on the distance, and I think we have to switch. Basically the same, but we had to negative on this distance, maybe. Oh no, maybe it's the other way around. Whoa, shooting lasers. Zoom. Ones that there'll be a standard that everyone agrees on, and the next GPUs will be rendered obsolete with new technology. Yeah. GPUs are like, I don't know, they keep trying to do new stuff, but then like mesh shaders have come along, and then like not many people are actually like implementing them. Hooked on Neovim. Sweet, good man. Except for one of the very normal SDF shaders. Oh yeah. Look at that boy. Right, I see what you're saying. Say if you had all your objects in the scene, you can define it in a shader. And you can compile it into the shader. Yeah, of course you can. But we're not. But then you're compiling those number of objects into the scene. Yeah. I see what you're saying. Yeah, so we're basically defining the object's CPU side. But I'm not sure why you would compile it into the shader, because then it's very fixed. If you're doing like a nice demo, it's a great idea. But when it's all orchestrated by the CPU, I'm not sure how you do it. You can have if statements where it's stopping from rendering, but that's about it. But yeah. Negative D, I think. Let's try that. Oh, well. Maybe it is just negative distance, but I thought I had to swap it around the other way. Right, that's still wrong. Yeah, deeply nested expressions. I think my compiler might be fine with that one, actually. I don't think it's too much of a problem. Just a tree, just allocate more memory. Right, so it is different. It's a plus here. Whoops. Right, so that's still a bit wrong because it's going to be a subtract. It's the same sort of problem we had before, where it's like, the I think you want to make this one D, this one negative D rather. Negative D, then this one's distance. Ugh. What did we have before? But we did that, we'd have to switch H. Maybe you have to say negative D here instead. Oh yeah, we got it, I think. Is that right? You're smoothing the subtract. I think that's right. Yes, that is. Good. Sweet. Right, we're getting nearly 2 ms now. Really tanking that performance, just as we like to see, right? So we can see how good the optimization will be. I'm so confused about Linux graphics. I don't understand OpenGL, EGL, KMS, DMR, hardware acceleration, resources online are very confusing me. Any tips to see? There's like, are you looking at doing like kernel development for graphics? Because then there's a whole stack of things to understand. And it'll be Euclidean. Maybe. Yes. Yes, they do. Yep. I think there's different ways of doing it. I think there's different functions you can use. But yeah, I think it is so. Powerful tool is as you construct complex organic shapes without geometrical seams, nor broken Boolean operations produce. There are many flavors such functions, but the basic ones are minimum. Wait, did I get this one right? Let's just double check. Oh shoot. My thing was a bit off. I shouldn't have copied and pasted the other one. There's a plus there. I copied and pasted this one over. Okay, we got that plus. There's a minus here as well. Yeah, bugger. Copy paste is the worst tool in the world. Alright, it should be the same. Right. Okay. So I worked on a. So it might be you have to say. Yeah, I did the plus there. I got that one, I think. Yeah. I got it earlier, but missed out the others. There we go. Yeah, I think it's Euclidean still. Because it's just smooth. It's adding more of it, maybe. I think it is. Yeah, copy is great. Paste is the villain. Maybe. Yes. The only technology needs is software rendering. Yeah, but it's slow. Alright, it's great if you want to make a movie. Yeah, software rendering is fun though, because you can get going really quick with it. Whereas GPUs, you're like GPUs are overcomplicated. Hence why we're doing this compute only, so we don't have to deal with basically like 70% of the complication of GPU APIs. But yeah, I guess mentally toxic. What like how much do you know? Have you done OpenGL? Have you done any graphics programming? Like what sort of graphics programming have you done? Um, I'm doing GUI development and I'm on embedded, running into so many issues because I don't know how things work. Using Qt. Oh, right. Okay, so you're high level up the stack. I see. So basically, you don't need to care about KMS or DRM. All you need to care about is OpenGL, EGL, and Vulkan. So Vulkan and OpenGL are what Qt used to render stuff. There's hardware acceleration on the GPU. EGL is a thing that they might use to open up a connection it's the way that it's a cross-platform way to make a render an image in a window, basically. Like it's a way to say to X11, like I want a surface where I can render my pixels to, and then X11's like, right, I will create that for you and I'll give you back a handle that you can use in OpenGL. For Vulkan, you don't have EGL because Vulkan just has its own thing where it can create that surface basically as an extension. But yeah, you basically don't have to worry about that sort of stuff because Qt does it all for you, right? Pretty sure. Every time I create piles of code, I get confronted with how intuitive regarding how performance is. I often feel like there's no way this could be fast, and then my GPU shrugs and blasts through it. Incredible. Yeah, we've got that down on the checklist. We've got I was also want to do skewing as well. You know, a good bit of skewing. It's down here, transforms. So we've just done these two now. We'll be doing the color ops soon, doing the texturing. But yeah, then look at transforms, clipping as well. See, the thing is though, in the past, I was doing some text editor and I was doing this sort of craziness for the text editor rendering as well. And basically, we had clipping using sign distance fields. So it it was bananas. Like you could define your clipping shapes out of SDFs and even smooth it so it's sort of like based on the distance, it sort of alpha blends the edges. So you can basically, honestly, it was bananas. So I might want to do that as well. But again, this is adding so much complication compute. And I hope the optimization that we do, like, just makes it go brr, you know. All right, let's chuck this bugger in here. Oh, right. This time I copied and paste this one. You know what? How similar is it to the other one? All right, let's take the first one, I think. Screw it. Let's do the evil paste. So what we want to achieve is a negative there. And it was the right order. Good. And then we want to have a plus there. Right, that ought to be good enough. Alright, I think that looks good. Smooth intersection. There we go. Right. Things are going places. Just double check that one. Okay. Mount. There's a K here. Oh, that's K. Oh, that's K. That's good. Sweet. Right, we're looking good. So. So let's tick that off the to-do list. There we go. So we've done all this today already. That's pretty decent, I would say. The next thing is we want to do some color operations. So we've already got two. We've got solid color and we've got border. So it just does a border from the distance. Wait, that one should be further back. So we want to add texturing. We want to add glyph support again. We had it before. And then we also want to add gradient, maybe, for a bit of fun. So let's take a gander. So we've done the texturing before, so I'm gonna go and grab that code. And then we're going to, so color, something like this. Let's have a bit of a look. Right, all right. Oh, so the thing is, in the old code, the shape and the operation were combined. So the shape and the color were combined. So this was just a box. We've already got the distances. All we're trying to do is work out the color. So what we're saying is, right. So the UV is passed in. If we go to the code, see here we say color, like basically there's like a bottom left, and then there's like a size in UV space passed in. So we'll fish those out. We've got some lovely ways of doing that. F32 times 2. UV bottom left. Add 2 words for me, please. I want to extract out a F32 times 2 from the words, please. And then I also want to extract out a size. Right. So how does one texture these guys, right? How do we texture an odd shape? So what we want to do is we need to have a bounding box, right? And then effectively the SDF acts like a mask, right? And then we color the pixels. We just sample, this bottom left would be the bottom left UV and going up to the, so it's quite simple really, but we need to get that correct. So what we want to have is like essentially a difference between the bottom left, so we've got a coord which is a float, is pixels. We want that to take away the bottom left of the bottom left of the draw command. So then that's simply a sub F32 times 2. And then that'll get you this thing called a yeah, that'll give you like a difference, I guess. Catch up the chat. Thank you, the blocks Ray. Thank you, appreciate it. Try playing a text string. Fancy. Yeah, that'd be nice. CPP. Look at CPP. What? Well, Derek templates. Amazing. What? How does one meant to solve this problem? And you pass in like a closure? What's the problem exactly? Yeah, this is just unreadable. So that goes in as the argument of the function. Oh, that stood function. Yes. Oh no. The problem is you need stood function, right? Because you've got the problem is that allocates like a lambda is the captured state is a structure of captured state that's like put somewhere usually in the call stack, but then stood function I imagine allocates that on the heap, and then you sort of like, so because you're doing variable arguments of closures, right, you have to have that dynamically done. Otherwise, the way you'd do it is you would template the closure, right? Is that right? Oh my days! This will make me. Sorry, I'm sorry, Sally. This will make my brain fry. See the difference from the bottom left of the bounding box of the draw command that we're trying to draw. So you got this box around here, for instance, which we haven't done the box yet, but imagine there's a box. You're taking the difference from the pixel, so you get like a vector to it, basically. So given that, right, you've got so you got the difference. Now, so UV space is 0 to 1. So you just multiply it by the size, and that will get you the offset in UV space. So basically, you say UV bottom left, I think, right? So you say like add F32 times 2, and then that'll just be mol F32 times 2 diff and UV size, right? Then you do your sample from the texture. Bear in mind you haven't got the texture in it yet. Oops, I forgot 2 words, right? I forgot a U32 for the texture. HCCRO texture 2D of float. Wait, F32 times 4. So here's your texture. So I need to cast. I think it's implicit. Implicitly cast, but screw it, or explicitly cast it. Oh no, implicitly cast. That's fine. Then we also want to get the sampler out. So there's a lot of stuff that goes in. Yeah, I'm not sure how good that is, but yeah, because that's like 6 words per texture that gets colored in, but the shape. But I don't know. Things. Yeah, maybe we can think about optimizing that at some point. So that'll just be texture sampler. So you're setting the source color to that, and we break. Right, that looks good enough to me. All we got to do now is actually get the bounding box. So if I compile it as 2D like that. Sweet. We're gonna get this bottom left. See, there's also a maybe we don't need a bounding. Maybe we just need a bottom left. Is that right? Wait a minute. I might need the size of the box to do the division. Bottom left. So I think the part of the issue is oh wait, did I just delete some of the code? Bugger. No, I didn't. Alright, it's fine. So I think the problem is to do with this here. Like, we need to convert this difference, like, because this is in screen space, and you kind of want right. So this is the difference in screen space in pixels, and you need to say like how far in is this pixel in the space of screen space diff in probably local space. So that'll just be diff screen space. So you need to sort of like divide it by the actual overall size. So div f32 times 2, and then that would just be like command AABB bottom left AABB half size. Wait, are we doing a half size? No, I want to do like a full-on size. Dims, I guess. Right, some of that. So you've got, so that will give you a value from 0 to 1, right? Unorm, right? In pixels, I'll give you a unorm value. Then you want to get the then you actually get the offset, the UV offset, which will then be this thing here, right? So having UV space. So maybe we call it offset UV. Much better. Much better. So that would just be offset screen space, offset local space. Voila. So then, see, obviously we could optimize this to call it inverse dimensions, and then that will solve the problem of it being a divide. But yeah, we can obviously look into that when we do an optimization pass. Make a game engine C. We're not making a game engine, it's a game without an engine. No engine at all. Okay. There's engine-like code, but it's all specific for a game. But yeah, C is the way. No CPP. But yeah, so we're doing this completely from scratch, and there is basically there's a VOD channel if anyone wants to catch up. But also, if you want to get access to the code, if you support via Twitch or if you support via Ko-Fi, it's kind of better for me really, because Twitch takes 50%. But it's the same price. You can join the Discord to check out. Wait, that link, wrong one. It takes you to the same Discord, just that one takes you to the channel with the information in it. And you'll be able to download the code and see exactly how all this works. Yeah, I think that's the right UV then. Good. So what we need to do is we need to now actually put a texture in. So what we're gonna do is we're gonna do a thing. Why have I got my Discord open still? Goodbye to you. So we run it. It breaks, right? Okay, very nice. Why does it break? Oh, because it won't compile. Right. Sure. So right now our command doesn't really have like a header of any kind. So we're going to add like a header now. So what happens is we kind of need to take note. Well, we kind of do. We kind of need to take note where they are. Got a simplistic start. We're going to add 4 words in. Just chuck them in there. Just like that. 4 words. Bam. And the reason is... Oh, wait. Sorry. So this would be like basically command bottom left and so for this one and command ABB dims. So should we do inverse dims? It'll just be way better. Let's just do it because I think the only place it's going to use it is this one. Let's do inverse dimensions. Then we get multiply and it'll just be cheaper. Mul. There we go. Jobs are good. So we pre-allocate the words there. Then at the end, when we do the finish, and we basically add the draw command onto the list, what we need to do is we need to fill in based on the start. We need to fill in the bounding box. So how does one do that? Where's the words? GUI dot words. Wait a minute. Wait, you don't want it to use captures, Sully? Then you can just use function pointers, right? Have they got the same? Yeah, because lambda's cast into function pointers. What? Right. Alright, it's actually getting really warm in here. I'm just gonna go and quickly fill up my bottle of water so I'm staying nice and hydrated. But we're gonna be adding the access line bounding box here. And I just thought we might not want to pass in the inverse dimensions, because we might want to use that box for another optimization in the future, but I'll just think about that when we get back. So enjoy the tunes. I'll be back in a sec. Oh. Man, it's baking warm. Bacon hot. Got a nice Pepsi Max. Oh. Okay. So we was thinking we need to add like a bounding box to this draw command. Now the thought was there could be an optimization, right? With the bounding box passed in to avoid doing any. So bear in mind we're at 2 ms here, and we can add this optimization in now. But there's another big optimization that I do, which will just cut this thing down by a whole load, because we're gonna basically, instead of running every draw command per pixel, we'll only run it. We're gonna bin them per tile on the screen, and they'll have a small array to go over rather than every single draw command that goes over the whole screen, right? So that's an optimization done in the future, but there's so we need the bounding box, because that's how we decide how it goes into the tile in the first place, right? So we're probably better off yeah, screw it. Yeah, we don't. Inverse is not good. We might. Like, we could maybe like get away with using float 16s or a smaller, like, or doing a custom 16-bit integer quantization, right? But that's an optimization that we can do if it seems worth it. But anyway, we're adding a bounding box. So how do we do bounding boxes? So we're gonna make one. Back to the Pepsi. Oh yeah. So I had like a root beer today as well. That was good. It's too warm. Thank you. Yeah, it's just we're just doing a single compilation unit right now, and as soon as so we're just including every single C file into the main C file, and until that proves problematic, we won't bother doing anything more complicated. Like, you know, we might have part of the code base which, for instance, needs to be optimized always for some reason, because otherwise, if not, the game is slow as crap. So you might need to like pre-compile that one and only rebuild it when it's changed. You know, so until we need stuff like that, or maybe we have so much code that recompiling everything's just insane thing to do. So until we need those things, we don't have to write. We're going to be writing a custom build system if we need it, right? Basically, just it's pretty easy. You can just do. Clang can give you the dependencies for every file when you compile it. So it basically isn't hard with some timestamps to make a custom build system. It's pretty easy. Easy peasy. In before all the SDFs are so cheap, they're not. In before. What do you mean very much? Do you mean like? Huh? These are all 2D SDFs, so I doubt optimization would be necessary. Well, I'm running the bench, like the benchmark, and we're hitting like that's a lot already. Right. Oh, so you're saying this is so cheap that it shouldn't be a problem. Right. So the problem is that we're running. Right. So if we tile it, then this shouldn't be a problem. I guess what you're saying. Yeah, because the problem is that we're running all of this over every single pixel, and it's just not going to scale. Not going to scale. Yeah, this whole thing, not all of this, sorry, all of this and all of that takes 2 ms basically, because I'm running it. All of those run over per pixel. Yeah. So I don't know what the problem is. It could be the fact that we've got. It could be that we've got so many switch statements that there's tons of registers being allocated. So I'm gonna have to research into it really. We might compile it into AMD's instruction set architecture, RDNA2's one, and get some stats back and just check. Because then we can actually make some decisions on how to fix that. Like, I might have to put a little thing above here. I know you can like say like, see, I'm not familiar on this, but you can tell it to generate the code differently for branches. So yeah, so we don't make sure this takes an impact on any of that stuff, right? Right, so how we're going to generate a bounding box. So in the internals, we want to basically just have like, so you want to min max probably, right? Min max, and then we can sort out that way. So I guess bottom left, top right. Ta-da. So right, so when we code it in here, it's literally just going to be GUI bottom left dot x. Then we've got to do that super lovely address of U32 cast dref, right? Then we want to calculate the bounding box. So that'll just be so we subtract top left from bottom right. That'll get you the super lovely oh shoot, did that wrong. Sub underscore, there we go. So you got the dims. So that is simply that one. So we put it in local so we can do this. Dims dot x AABB, and voila, magic. So this is the so we say patch the draw commands AABB. So now a super massive big shader. So the optimization could go, so we're going to have another shader that runs before which bins them per tile, but furthermore there could be another optimization that you could do. I don't know how, I really don't know. Oh, we should probably remove it, or at least test it, at least see if it's worth it, because if it's inside the tile it's probably going to cover all the pixels anyway, 8 by 8. But let's put it in here just to see how quick it makes the shader. So we're going to pull them out here. So we're going to say F32 times 2. Right. So we pull out the command AABB bottom left, and then we pull out the command ABB dims, right? And then we can do our super nice, like we've got the pixel coord, so we can simply just say, hey, if yeah, so we should just be able to say if coordinate, if command AABB bottom left dot x is less than or equal to all right, if this is less than that one, or less than, I'm going to say dot y, aren't I? Or plus command dims plus command AABB dims dot x is greater than it might be greater than or equal to. Let me have a bit of a think. Then we do a continue. So that should optimize it quite a bit. So your final coordinate is in yeah, that'll equal something like that. Sweet. Ought to be good enough. Trying to catch up a bit last. Hey there, MTG card Jeff. We're simply doing, well, where's my Twitter? Here we go. So a couple of streams ago we decided to try and do some UI rendering using nothing but compute shaders. So we got these sort of like circle working and a rounded ABB, like axis line bounding box, and an axis line bounding box here. Got a glyph rendering and a texture with some alpha blending, stuff like this. And so the way this works is we done front to back alpha blending, and when the pixel was fully opaque, so we process every single shape that you're seeing on here, front to back per pixel. Wait, I said that a bit wrong. per pixel, we're processing every shape, front to back. There we go. And as soon as the alpha is 1, we just stop processing any more, and then that's the final pixel color. So we do this in compute shaders, and then I realized that we're basically defining this rounded box and this ABB as and then we've got like this texture here, which is kind of like an ABB as well. And what I realized is we're mixing like a shape and a color into one thing. So we've kind of decided to separate those things and make this sort of like sign distance field. So we use sign distance fields to essentially like make the shape, and then you can like color it in. So we make like a list of commands that then get executed on the GPU in a compute shader per pixel, and that computes basically the shape you're seeing here. But yeah, so essentially we're making this like super awesome flexible way of defining some shape that you can then color in very interesting ways. Like we've got this border here that goes around the edge. We can texture it, all sorts of goodness. But yeah, it's also running quite slow at the moment because of the flexibility, but we're planning on making it super quick, hopefully. Okay, I just realized with front to back alpha blending, maybe marching through the shapes would be fast, since you basically skip all the fragments that already have the shape there. Yes, so if you, yeah, that's right. So if you've got tons of overlapping stuff, you will skip it. You'll skip all the stuff behind it, right? Yeah, that's right. Yep. Yeah, I'll work at MM. Yeah, I'm actually going back tomorrow. I've been off for 5 weeks. Yeah, I have not worked there since I worked there since the like towards the end of Dreams, basically. So yeah, we're working on a new thing now. But yeah, I got to put some stuff out in Dreams, so that's cool. So I think that reads okay. So this is a way of like do we really need this when we do a tiled when we bin the draw commands in tiles. Warning, make sure that the word index is skipped here if we remove this. Cool, so that should be good enough. Fingers crossed it all works. What is diff? Diff is meant to be, wait a minute. Offset UV, voila. Cool, what is all this? No case for right. Because it's meant to be sample texture. No. Right, so I've got to change HCC now. I've reached the end of an array size. Something is a little bit wrong. Current basic block. Right, so in the compiler, we've got a bit of an issue where the pre-allocated array has not got enough words. For the instructions. So that is purely because the code that we use to estimate has not been generous enough. So why is that? Crap. There's not too many places to check actually, so we can get... Right, let's hop over to HCC and sort that out. Right, here we go. So if we go into the AST gen, we basically we do the syntax tree and we can sort of, I forgot the thing, but it's like, something to do with the AML, something. So if we go to like a function call, we can say at the bottom, there you go, max instructions count. So I think, yeah, here is C compiler. That's right. So we use it for the shaders, so we can compile our shaders into SpearV. So we've got a lot of little function calls, but those go out to intrinsics. That's the problem, is these fold out into intrinsics. I think. But then, is that really the problem? So you would know what the function is already, which means we can say if it's an intrinsic. Come on. Where are you, bugger? Function expression. So that it's a function, we have no function pointer support. Function decal. Do we say if it's an intrinsic or not? We don't. Yeah, I think this is where the biggest problems come from then. Because we do use a lot of intrinsics, which means... So if it's an intrinsic... No. Let's have a look at that. Let's see how this gets used when we lower it. So when you lower it to the abstract machine language, we say, hey, if it's an intrinsic, here. It just maps to a convert. Right, but this one wants to also generate a load, right? This one here, if it's a many not, manys, any's, they do some things, right? So maybe, oh, and a sample does some extra bells and whistles too. Right, so I think we've found our culprit here. So if we up this number, so really we should say, hey, if it's like an intrinsic, how does that generate? It generates one new instruction, which probably has a couple of words on it. Yeah, so maybe we do like 16 or something. Give it a good number. So if it's an intrinsic, give it 16. Bum, 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 bum. Right, so if call the expression, yep. And this means it's an intrinsic. So it can end up, so it can be multiple instructions. So let's say it's like maybe 8 at most. So that should hopefully be enough, and it should fix that problem. Cool. So I want to compile it, bring the new version over. So we just run the super lovely build script. Wait, we want to run the release build because then it's optimized and our compile times are fast. But we don't really compile a lot of code, but anyway. Ta-da! So we should just be able to now go into the workbench, HCC, go into the build, grab, or what do we want to do? So I think we just need to grab the give me a sec. I forgot how we did this. Right, it's the release package, isn't it? But all we should have changed. Oh, and then there's the Windows version as well. Yeah, the Windows version as well. Right, so I've got some things to do after the stream, it appears to be. Right, so what we're going to do is we're going to go into HCC, grab just the executable because that's all that's changed. But we've got to remember to do the Windows version as well. Man. Wait. Third party HCC, drop that one in there. Right. Let's chuck some stuff on that to-do list. Right. So we need to commit HCC changes, right? And, go to Windows, compile HCC, and update hcc.exe in third party. Oh. Anyway, so that ought to fix the problem. Bam, look at that. Right. That's how you make those changes. So, right, back to where we were. It's running now. It appears to be quicker on the MS 1.2, but we're getting a black screen, so obviously something is hella wrong. So, why? Oh, why? Is it wrong? Is it because of this continue statement here? But now it's all... something's wrong. Have a look. Whoa. Yeah, this is basically what we do. But we just do it in some virtual machine on the GPU, basically. We're just doing this, in a way. Nice. Oh yeah. Right. So this, but then the colors buggered up as well for some reason. Like, why is that? So, what have we done? What did we do? So we added. Did we add a texture in the end? Right. I didn't put a texture thing in here. So something is definitely fishy. So we added the code for texture. Right. But we also added this thing. We skipped 2 words. Do you always push the A, B to the stack? I think we do. Because the shapes are coming through fine, but the color is off now. But the color's always at the end. So maybe it's missing... Right. So this thing starts, when this thing starts off, here we go. So we add 4 words. All right. Oh, we did a thing. We did a thing. Sorry. This needs to be up by 4 as well. So there's like, it's not the most, right. That's the problem. So basically there's an array of draw words, but then there's like how many words does this draw command have? And that's what the other one is. So we was missing 4 at the end. There we go. Cool. So we're back in business. So let's put the continue in there and see what happens. So the continue is broken. So the continue is misfiring, so you can't take those results as anything. So if coord.x is less than bottom left, or if it's less than, or if the bottom is less than the y, yeah, or if x is greater than or equal to, that looks sensible to me. And maybe we should like just do this, right? Because it might be easier to read. I was thinking that, but then I thought it's greater than or equal to. Oh, for the first y comparison, if the coordinate, the pixel coordinate is less than the bottom left. No. No, I've done it the other. We're checking if it's out of bounds, right? So we're checking if. So you got your box. Let's get this over here. So you got your box. So if your coordinate, this coordinate, is less than this left-hand side here, this left-hand side here, then it's outside. If this coordinate is less than this y, it's outside. Yeah, it's the other way around. Or if it's greater than or equal to. So I think my dims are. Something's up. Something is a fishy. Something is a fishy. Yeah. Hey there, meatball one. How you doing? Fishy, fishy. So you put the dims in there. You do your start words. Let's have a look at that one. So you start it off there. Yeah, that's good. I think. See, we could just draw it. You know. That's another thing we could do. We could say, hey, if it is there, but then the whole screen will go red. So maybe not. I was gonna say like make it a red pixel, but then no. Probably not a good idea. What are these words? Are U32s? That's correct. Good. So we're taking the F32. Wait, how dark is it? Okay. We'll get a line in a minute. Oh, these guys. No, because when we start it again, we set them here. I think that's fine. Yeah, good catch though. Yeah, draw fishy. If if you're a crazy mathematician like IQ, the guy who makes Shader toy, there is an SDF dolphin. If you don't know this, SDF dolphin. It's made by IQ himself. Look at that. There's even multiple dolphin SDFs. There's a cheap one for the collision, so the water comes out right. There you go, SDF dolphin. Yeah, animated cartoon girl. He has a wizard. There it is. That's all the maths for for a dolphin SDF. Absolute wizard. Looks great, doesn't it? Can you imagine if this guy made like a whole film using like SDFs? That'd just be funny. Just programming scenes in pure GLSL and rendering them out. That would be amazing. Yeah, that guy's a wizard. Right, I'm gonna switch on the light. Ooh. You can think of it as make any 2D surface with some numbers. That's how wavelets work. Yeah. Yep. It's clever. So take the address, I cast it to a pointer U32, deref it, right? So that's like a reinterpret cast. Nothing wrong there, right? So we've got the top right, which is the map. Guys, we didn't even fill anything in. Oh, I'm such a twat. So we programmed this all in and was like, oh yeah. It's good, right? But we didn't even go actually do the min max. So here you go. So in the implicit start, right? Firstly, you set these to like positive infinity, negative infinity, all that jazz, right? So infinity, infinity, and then such a melon. Right, infinity, and then this one will be negative. Wait. Yeah, because you min this one, you max the other one. Good. So in shape ABB, for instance, let's do circle first because it's up here. So you're simply just going to do, hey, can I get the min of this with, so you get your actual like top right. Do we need top right? So it might be easier just to do a bottom left. And then a screw it. So it'll just be add F32 times 2 center position plus radius. Add S because it's doing a scalar. Radio, so that's a min, and the other one is a max. So wait. Max, min, sub. Oh yeah. So then we take this one, put it here. So you got the AABB. This is obviously the half size. And we get rid of the S because it's not a scalar, it's another vector. And voila. So hopefully that will be correct. Right. So I don't think that really improved much. Yeah, it saved like 0.2 ms, but it worked. So I don't know whether it spent the maybe the AABBs are wrong, but we can draw them. We can draw them now. So we can color them based on the command index, right? So we'll hash it up or something. Right. Let's check the chat. Hey there, Bam Kudia. Welcome. How you doing? Check this one out. Woo. Oh. Oh wow, they actually go down to the asteroids. Oh my days. They're actually rendering asteroids. SOBs. Just wait till it gets to the asteroid. Right, and then they go down to the Earth. Oh no. Oh no. Oh no. Atmosphere? Then water. Does it keep going? But wait, there's an underground civilization. Oh my days, even got this. What? Oh my days. But yeah, they might have different if statements, I imagine. What you thinking, very much? Yeah, if statements. Yeah, now just add the dolphins. You know, you can have a ring of dolphins. You know, clearly missing out. And these are advanced tech of an if statement. Yeah. Basically switching scenes, right? Okay, so right, what's the next thing we need to figure out? Is this thing what we think it is, right? So what we'll do here. So the end result is like if you skip the shape. Yeah, but every pixel's running this. So the ones that are not skipping, Oh. Right, how can we figure out the ones right, so obviously let's try and color in every pixel that is not a see, I don't know if it's a good idea. See, if I start this off as red, it's not gonna work, is it? No. Right, because that makes okay, good. Right, so What I'm thinking is like, let's just put Boolean in here. Has drawn, something like that. We'll say false. Here we say has drawn equal true. Then at the bottom of this if statement, we say if it hasn't drawn, just make it red. If hasn't drawn, can you just make final color equal to F32 times 4, 1, 0, 0, 1. Excellent. That's what I wanted. So basically there's a bounding box and we're seeing it now, right? So every pixel that isn't inside the bounding box is showing up red. So what we're seeing is we're actually getting an optimization. Well, I've just disabled it, I think. Well, I've made the optimization go away with this if statement. It's added some time to it. But yeah, so what we're seeing is that the code is working. So this if statement works just fine. So per pixel, it still goes over every single draw. It extracts these out, and then goes to the next thing. Cool. What's our frame rate? It's 0.2 ms. Like that's how long it takes on the GPU. Wait a minute. That's really optimized, isn't it? Because it was reaching 2 ms, like 2 milliseconds. And then with this cutout, right, my brain for a second read it as we're still in the milliseconds, but we've dropped down into the into the microseconds. Yes, good. So it was reaching 2 ms without this optimization, right? But this is before binning. So I'm not sure how good this would be when we bin it per tile, because remember, every pixel goes over every single shape and tries to see, can we draw this here? Which is not good, because when the list gets big, you're going over a huge list and just doing a lot of testing. So we want to do a pre-pass where we chuck it into some tiles, like 8x8 size, and then only render the 8x8 size and have like a little array that we go over. So this is 2 milliseconds now, but then when we do this, it actually drops it down back into the microsecond range, which is good. So that should be decent. Yeah. Excellent. Right, so let's keep going. It renders differently with clipping, does it? Shoot. You're right. The boxes need to increase the right. So we still need to make this bounding box because oh, that'd be interesting. You could apply the texture to the growing box and it'll work. Cool. But yeah, we need the bounding box for the textures. There's the whole reason why we're doing it. It's not for... Right. So that's a good point. It wasn't working. Okay. Okay. So when we do that outline, it does get bigger. Oh my days. You know what? We've got to bring that thing back again. Ball, yes. Right, we'll keep this around just to make sure we get it right. If not, yes. 1. 5,000 FPS. Yeah. Right, so that's added a little bit of the microsecond. Yes, that's not as bad as I thought. I thought it was really undoing it all. Right, okay, it's good. So yeah, these are bugged up as you can tell. They're meant to be, yep. Right. So that's because we use an outline and rounded expand. So these should. So you got a bounding box. You just need to apply it to the bounding box. So GUI bottom left dot x take away. Well, you just say, okay, take away equal amount. These are plus equal. Now we go over 9,000. I'm sure we'll go over 9,000. Right, so that one's working. Look how good that is. Oh, now we'll get this one working. So we actually are going to be doing clipping at some point. I was hoping we'll kind of maybe get to think about it today. But yeah, I think we want to add some crazy SDF based clipping like I did in a previous project. It's complete bananas and awesome at the same time. Because you can, like, based on the distance, do some anti-aliasing. It's completely insane, and it's amazing. But yeah, there we go. We've got the box working. Voila. So that's good. Yeah, much better. Now this one, yeah, it's got the circle there. That's fine. That's fine. Right. Thank you for catching that, Kraz. I did not see that. I was too busy, just like, oh, works. Off you go. Hey there, Bella Lugosi. How you doing? Bella Lugosi. Gotcha. Probably butchering that, but it sounds great. Ever thought to use some Raylib in your project? So Raylib is like a framework thing in a way. It's like it provides a whole bunch of like stuff that it does for you, whereas we want to. Well, it's like a library that does everything, or has different libraries that do things. You know, but we kind of want to write that stuff specifically for our game. And we want to do some interesting things which are not in these other projects, where we have our own thoughts and opinions, and also want to do something that's quite unique. So if I use someone else's thing, I'm stuck into using their thing. Whereas here we get to do some crazy SDF stuff, and have extreme flexibility, and do something which is not different. Do something that's different, you know. We like different. Right, so what's the next thing on the checklist? Oh, textures. Was doing that one week. So now with the bounding box, we can actually do a texture. So we wrote the texturing code. So let's go ahead and define ourselves a. So we'll copy this one here, and we're going to texture it. So bring this one down below. It's going to be amazing. It's going to blow your socks off. Where's the bugger? This one. So we're going to copy this one and go down below. So that is another 240. And then instead of doing the color border, we're going to say color texture. Now it takes in a texture ID and a sampler. So we've got ourselves the texture. If we go to ggfx.logo texture ID, that's the HeroDev logo that you see in the Be Right Back screen and the warm-up stream. And then we're also going to chuck in a clamp linear sampler. Rightio, chuck in that boy, and voila, there we go. I'm glad that worked first time. Right, but now we want to try and now here's But the problem is like, you see the edges are... Wait, the edge is meant to be black. Yep, that's right. That is right. So let's put a border on it as well. And then let's also like pan the UVs, because that'd be a bit fun. So we'll just do a bit of pan. So what we're going to do is we're going to chuck that border code that we got rid of. Just grab it, put it there again. And you'll see how it just multiplies the two together. So it's kept the border, and it's put the purple there as well. Yeah. So you could, yeah, so we could, yeah, it sort of tints it. I might want to just make the inner white, to be honest. Is that right? 2, 3, one more F. Not enough Fs. There we go. Wait, it's a bit off. Shoot. 1 byte, 2 byte, 3 byte, 4 byte. Come on. Oh, that's outer, that's why. Inner. I always get that wrong. Inner, outer, done. There we go. So there's the logo with a bit of a border going on. So what we want to do now, it's just showing you can add multiple ways of coloring it. We want to do a sort of a UV that sort of goes around. So you want to provide a size and an offset. So the offset is probably just going to be, I don't know actually, we'll think about that one. Doing great, ordered an external floppy disk drive, so on Tuesday I'll be having fun with some DOS games, making a game fit on a floppy. Cool. Nice. Yeah, that was completely the era I wasn't around in. I just, yeah, sounds cool though. Like, I kind of sometimes like wish I was born a bit earlier, so I didn't kind of have the exposure to all the garbage modern programming stuff, you know what I mean? Learn more because I would have been, providing that the circumstances would have been the same, I would have been really into technology and wanting to learn it, you know. Could be fun to make a game. Each stage, the evolution, the engine that uses the capabilities. Where could be fun to make a game at each stage of the evolution of the engine. Yeah. Yeah, so essentially, like, when we finish this game, like, and we want to build another game, like, the engine just doesn't get thrown in the bin. We'll probably like a lot of the stuff, and maybe you might make a version 2 of the game and just copy paste the code over. Or you might, you know, so it's not going to get thrown away, but the idea is like the code just stay, like you don't have a shared library that you sort of like have to maintain or have to make sure that all these other previous projects work with the new version of the library or anything, or you can just copy paste the code over and start a new project and just delete code that you don't need anymore. You know. If I was born today, I probably would hate it and never get involved into programming, probably. Yeah. You know, people must think like AI as well will just take everyone's jobs as well, so there's probably that fear. Right, let's get a little offset going on. So we want to do an offset. How does one do an offset in UV space? So you probably want to just get something going around, right? So the best way to do that is just sine and cosine, basically. So if you take this round radius, we'll just take that one. We shall basically do a F32 times 2. So I always forget which way it is, but I think it's sine. Wait a minute. Cosine starts at 1, so that's your x. Then you say round radius, for instance. then that'll be 0 to 1. Wait, minus 1 to 1. So it's minus 1 to 1. So you times by 0.5 plus 0.5. Then that's 0 to 1. Now, 0 to 1 is a bit much. So what you really want to do... See, I need to chuck this in some form of like UV bottom left. Right. So the problem is that is too much. So if you basically divide it by 0.25, then you probably want to add an offset of probably something like 0.25 as well. Maybe 0.1, something like that. So it's not just going around the bottom left a bit. Something like that. Then I think we can do that for the Y as well with sine. So that gives you, it starts off at 0 instead of 1. Right, voila. Amazing. So sine f32. Cool. UV bottom left. You're in the area of floppy disk, but you just enjoy the limited of being limited to make life more difficult. Attempts of learning assembly, complete useless skill at this point. Not really. Like, you know, it's pretty... You know, I think some people like start off by just programming for old consoles. It's not, you know, it's a desire to have a more simple thing to program. You know, programming for PCs nowadays is ridiculous. You know, we're doing a game from scratch here. We're episode 30. We've got a graphics API, or our own GPU API, right? We've got controller support, Windows, Linux. It's taken us 30 days of work, and we're doing this UI thing as well. Whereas if you had more limited hardware, you know, more simple hardware rather, it would just be, you'd be a lot further than I am today. But this is part of the point as well, is like things are really complicated, but there's a simple path. And you're also going to watch me overcomplicate this path because everyone does it. And you just got to try and, like, you'll watch me convince myself that I need to be more complicated than I am. And this is than I need to be. And hopefully this thing we're doing this with this SDFs is not right. I'm hoping that this is going to be really powerful and we can use this to sort of like construct something that's very unique. Or maybe it's not unique. Maybe people do this already, right? Do this anyway. Is it HTC VODs? No. I started doing VODs. I wanted to do VODs, and then but I was like halfway through the project by then, so kind of a bit pointless, unfortunately. But yeah, it would have been cool. Right, let's do 0.5. Hopefully that's enough size. Right, and then we just say texture with an explicit UV, and voila. Hopefully that'll work. Right, way too fast as you can see, but stuff is happening. So if we look at this, what we're doing. What is going on? You can barely even learn real knowledge anymore. Like, how do caches work? Do they really work like that? How do we know? I remember an AMD guy told me that for some OpenGL application, the driver never creates a depth buffer and just keeps a list of triangles and tests every pixel against that. instead of ever allocating depth buffer because it was faster. Crazy. Yeah, I think with GPUs they have a lot more. They have a lot more room for really weird. They have a lot more room for optimization. But yeah, um, it is very difficult to learn how hardware works. You really have to have a play with it and understand theory that you mostly probably get from reading random bits on the internet, piecing it together because it is really complicated. And this is going way too fast. I need to scale this radius down by about 0.1, something like that, right? Way too fast. Look, I did a thing. It does go back and forth like that. That's how we program it. So I think that 0.25 that we add, a little bit too much, let's say 1. And then I want to up the size a bit. That final offset. I want to up that size a bit to like 7. Not 757. There we go. So got a bit of a zoomed in texture and we're sort of rotating around it. Good enough just to prove that it works with the maths that we've got doing the texture sampling. So I'm happy with that. Good, that's texturing done. So let's add glyph support. Texturing is a done. So glyphs. So we added glyph support before. If we go back to the, we've done a very simple bitmap glyph. In future, we're probably going to just do use like SDB TrueType or FreeType lib, one of those libraries, and just get it to rasterize it on the CPU and just have a font cache. But for now, we don't really care how great the text specifically looks, and English, ASCII, good. So what we're going to be doing is simply just sort that one out. Right, so let's do so the thing is you could do a circle that is then like colored in with a glyph, but we're just going to obviously just do a box. But yeah, we'll sort that out. Glyph, color with a glyph, good. So all we need to do when you color in a glyph is we just need the wait a minute. What do we want? We'll take in a U32. We'll take in a code point. Is that a good idea? Probably not. We need a glyph. We need to get a glyph. So we'll probably have a way to say like UI glyph ID from ASCII. And then if you want to have something more like UTF-8, there might be a sequence of code points that gets you something, right? I don't know. But for now, this will be good enough. And then you can that will get you your glyph. Glyph ID. And then we can use that. So at least we've got a function here. Well, 6502, if I'm not saying it wrong, Nez, was fun, but I gave up on the pick assembly since it was really weird. That's cool. Guess I try on Max 66. Nice. Very cool. Gives no. Well. Um. Tweed. Right, so I want to go to UI.h. So we want to add, I guess we'll just get a glyph section. Or text section. Or something. I have no idea. Glyph text, do a text section. We want to add something like this, right? So U32, this guy, take in a char, ASCII character, and then give me a glyph ID out of that, please. So I think this thing is going to be like really dumb. Like, for now. But, so this thing probably, so if it's a glyph ID, what is going to be useful inside of the, well, I think we'll just return ASCII. Right, and I know it's pointless, but it just means that we can capture every time we actually do this. Yeah, screw it. So I think we want to create this function as well. This one, so where's the UI shared. Right, so UI shared, we need to add a new guy. And this one is going to be glyph. We'll do that. So the internals, the public API. And we'll reorder that down like that. We'll add a new one called render glyph, please. Glyph ID. I don't think we need anything else. It should be sufficient. Just reorder this quick. Good. So we kind of, when we're doing a color, we call that color assert function, so it's all shared logic. We then put the glyph thing in there. Then we just need to poke in the glyph ID as a word, right, word argument, and that should be enough. Then in the shader code, all we have to do is add this lovely thing in. Now, basically, just take the textual one with us and reorder it so it's the same order as the other guys. That's my OCD kicking in. But I think we can copy a lot of this. So I've already got the texture and the sampler in what's known as the bundle constant. So this is what's passed into the shader. It's like 64 bytes at max. And when we call the shader or dispatch the shader down here, we fill it in CPU side, right? So we've got the font texture. We've also got the clamp nearest sampler chucked in here as well. So this is where we're going to be getting our texture from. Obviously, with a font cache, we might, yeah, I think we might have one texture still. With a font cache, maybe. Because when you start having more textures, it just gets weird. So in the shader then, all we have to do is just get rid of this texture, get rid of that one. We just need to extract actually the glyph ID. Wait, I just realized. If you put in the glyph ID into the shader, it's a bit wrong, isn't it? What you really want is a way to say, given this glyph ID, can I get a UV coordinate? So we kind of want to keep this. Something like that, right? So in the UI system, what you kind of want is a new internal function. And this will be kind of like given glyph, wait, text on it. So you kind of want like a UI, glyph ID. So you want to say like glyph texture UV bounds. So this will basically say to the cache, it will like look in the font cache. If it's not in there, or put it in there if it can, and if it can't, it just returns like a UV with 0 size, and then it just won't render anything, or give you some other glyph, right? Something like maybe a default glyph or whatever. I don't know, but we'll define that properly when we have it. So there's F30 times 2 UV bottom left out, and then we'll do another one which will be UV size out. So we'll just define that one. I forgot what order I did it in. Was it underneath or... Yeah, it's underneath, good. So the internals go underneath. Cool. So for this one, like the font image that we're using is just a pre-rastered, let's go, pre-rastered 16 by 16. So it gives you extended ASCII 256, right, things, right? So we just basically convert that ASCII character into a 2D coordinate, and then UV that thing. So the UV size is equal to 1 divided by 16. So like that, yeah. Then the bottom left out is equal to glyph ID. So on the X is mod, right? Mod 16. So it's in, you've also got to scale it down into UV space. So to scale it down into UV space, you probably just divide it by 16. Mod 16 divided by 16. Is that right? Then divide by 16, divide by 16, something like that. So if you've got so 0 to 15 that you kind of want, isn't it? Right, so if you have like 16 entries across the X, I lost my thing. So you have 16 entries across the X. When you mod it, you can get 0 to 15. So if you got 15 at the end and you say divide by 16, that gets you the bottom left. Yep. That'll be good. Right, that ought to be good enough. So we've got this bounds now. So when we do our glyph function call, we basically want to have all this stuff sorted out. So be UV bottom left, UV size. So that'll just be, hey, my glyph ID is this thing, and Oh, bear in mind we should have casted that into a... Right. We need to pop back to that function a sec. I think we need to cast it. Although maybe we don't. Right, then we push these two F32s on instead. So we could just do the glyph ID now and just do that in the shader code. But the problem is like in the future we'll have to change it anyway. So we'll just do this. So this would be oh, and it's U32. That's fine. Yeah, I thought it was still a char, you see, which is signed on x86. Right, so we get these, and now this texture is command dot wait, bc font, right, then bc clamp nearest sampler, and voila. So did we write the usage code? Glyph. So we're gonna do a H, right? Best character. There we go. So we've got a H in there. It's a little bit wide because obviously the shape that we use to draw the H is that way, right? So you know, really you just want to make it square, and then it would be fine. So what we'll do on the we haven't really got color, have we? So it's just black and white. Yeah, we need to put that in the... Ooh. Yeah, we solved that problem in the previous thing, but I just forgot about it this time. So let's say 400... Wait. It could be 300 width max. So maybe we could just do 200, I think. That's half size. A little bit too big. Can we drop that down to about 100, maybe? There we go. Cool. So the coloring is white by default. So, well, it's white because it's just sampled it straight from the texture. So really what it is, that is an alpha. So when you say color glyph, what you kind of want is a color with it. Because so the color can go, see, we could just declare it separate, like you no. Yeah, I think you need a color in with it. All right, there it is. So we'll change this a bit. We'll say, hey, can I have a color as well? Another word there, fair play. Because we could have said color glyph and then color solid, and that would have worked. HSVA. No, we use just RGBA. Yeah, we don't have that yet. So we could do color glyph followed by color solid, but that puts an extra 32-bit integer in to say that it is color solid, and it's another switch statement. And you probably want to do that. You want to do that every time anyway. So just encode it as part of the thing. So we pull out another word and it's color. So what did we do before in the previous one? It was color solid. There you go. Right. So it's something like this. So you unpack the 32-bit integer color, turn it to 4 floats, and then you get yourself a source color. Now, really this thing is you just want the red channel, and that's your alpha. See, we should be able to do some blending as well. Not blending, sorry, anti-aliasing. We did it here. We did some AA here, didn't we? No, maybe we missed it. Anyway. So we want something like this. Basically, unpack, multiply it by the alpha. Dot R for red. And let's try that. Not command dot color, sorry, just color. So let's just make it should make it like a green. Seems to be our favorite color. And there you go. Oh, so that's glyphs done now. Right, that is going a bit fast though. Can we drop that bit in speed a bit? Let's half it at least, right? I want to move it a little bit back from the... The Y was fine. The X wasn't. The Y needs to go up a bit. Wait, is that going down? Oh shoot. That's not clamp, is that repeat? Something's fishy. No concept of camera yet, I guess. No, nothing yet. The UVs are wrong though, they're not bottom left. Damn it. What a shame. The UVs are wrong. Because they're top left in Vulkan. See, I want to do bottom left for everything, because it's just really annoying when you have to say top left. And I just realized we've calculated the glyph thing wrong as well. So this should be uv.y. One take. Just invert it that way, right? Same thing for that. And then we want to run... But will that flip it? Will that invert it? And that'll flip you upside down, wouldn't it? No, you want to flip the... Before you add it, you want to flip it. So you want to say then top left. Something like that. So it's no longer bottom left anymore. There you go. Man. Because I think in OpenGL it was bottom left, and then in Vulkan they were like, no, origin's top left now. Like, it's in the SPIR-V code. Because when you emit the SPIR-V code, you have to say it's It's top left. It's really crazy. So yeah, keep us on the edge. I see what you're doing there. A nice pun. Yeah, they definitely keep us on the edge, the wrong edge. Bastards. Bastards. Flip to top left. You had a deep dive on this topic. Ooh. It's a shame people can specify a winding order of culling types. Sorry, culling triangles. Yeah. Because you do the pipeline stuff, isn't it? Yeah. So that would mean that my H is wrong. Yeah, it gives me the wrong glyph. Good. This is good. So that would mean that in my glyph lookup, my glyph, this guy, you need to do 16 take on the Y. Damn these top lefters. See, this is even top left. Because top left is there, you see? The 0, right? Top lefters. They ruin everything. There we go, H is back. So that would be, oh wait, is that right? 16 divided by 16 would be 1. 1 take. So someone's off. This is off by 1. Because that will give you 0. Wait. 16 take. Nothing is ever 16. Wait. Yeah, that'll never be 6. So glyph ID. So it's like this is 0, 0. This one will be 15, 0. So this, yeah, 15 will be 1. See, something's wrong. I think it could be in the shader. Oh no. I did my investigation. I learnt. I wanted to keep my notation of up or right out of the API at any cost. During my investigation, I learned that different cultures do their right-handed, left-handed coordinate systems differently based on how that culture counts with their hand. So X is always the finger you start. Oh boy. This is deep. The funny thing is American is like a gun. It's a bad joke, but yeah. Whereas like European is like, I don't know, what is that? Oh, Z is up. It is almost like an FU, isn't it? Yeah, America's like, pff, and the Europeans are just like got their finger up. It's all they can do. Yeah, it's all they can do. Y to the right, X forward. That is weird. No, X is to the right. Y backwards. What? Oh, to match the letters, right? What's up with this off by one error though? I am hella confused. So, I'm going to say 1 take 15 at most, which always gives you 1. So you'll be off by 1, though you'll never reach. Ah, screw this thing. We might need to, but then if I take the extra 1 away, then it doesn't, it gives me X, it's wrong. So, it's meant to be the bottom left UV. And if you really want to reach bottom left down there, like something is wrong. Like that's, because that never reaches. So it never reaches. Yeah, because it starts at 0. It's 0 based. So when I flip the UV in here, you add an offset UV to it. Adding is fine. Right, I'm gonna take a 2-minute break because it's getting quite warm. Gonna refill the drink, have a bit of a wonder, and then refresh my brain for a sec. Where's the tunes at? It's still going. Very good. Right, I'll be back in a second. What's this movement? One box in the middle. I think that's an intersection. This one? That's intersection. This one's subtract. Subtract intersection. Oh, this one? This one is the union. What do I subtract? This is 2 balls. So you've got a one circle, another circle, another circle. Yeah. No worries. So I'll give you time to catch up because I'm going to take a quick break. Yeah, smooth subtract. Yeah. But we do multiple subtracts. Yeah, turn up the smooth factor, yeah. Yeah, subtracting 2 balls, you know? Right, I'll be back in a sec. Hey everyone, welcome back. Whoa, let's go. Thank you, sir, for the sub. Appreciate it. Appreciate the thought. 6 months, eh? Fantastic. Radio. What we so yeah, we're trying to reverse that y coordinate, and we're just looking at it. What, like, it shouldn't be the way it is, right? So let's figure this out, right? So the number we should be getting, count from the bottom: 0, 1, 2, 3, 4, 5, 6, 7. My breath. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right, to hit bottom left to H should be 11. So what we're looking at is like, what is this? Is that 11? Hey, what is that? Oh, I need a thingy. Added thingy. Did I add thingy? Yeah, good. 12. Bum, bum, bum. It's all wrong. One too many as we thought, right? So that's why we did 15. Because it was off, you know, need the, or you could do that and take one more. Yeah, 15 is correct. So, but then, right, let's just change that so we see it in here. So you get 11, ta-da. But then it's wrong. Why is it wrong? So, obviously something in the shader is a bit wrong then. Because, well no, because then you flip it. And then, wait a minute, the texture. I just realized that the texture needs to be flipped upside down as well. Because the issue is like, so say if you aim for the bottom left of this H, what is glyph ID? Glyph ID is just an index. It goes along the X and then it goes down the Y by 1. So it's like we map an index to a 2D. Yeah, it's like a pixel index in a way, kinda, but for the rows and columns. Yeah, but for the glyphs instead. So the problem is that when we refer to it in bottom left coordinates here, right? And then we do a one take bottom left, one take bottom, right? What it gives you, it gives you the top left in, wait, what's the way of saying it? Yeah, you need to flip the texture upside down as well. Because if you flip the coordinate, it's gonna be, oh my days. What's the way of saying it? Yeah, so we have this coordinate at this bottom left of this H. Then you do one take this coordinate, so it puts it all the way down. It's as if it puts it down. It's as if you're flipping the texture upside down, and then when you add your thing, your size, it uses the X instead, so it keeps it on the top left. Right, this is the problem. This is why it works when you put it at the top left, right? Because when you flip it, it's as if the size goes down. But if we flip the texture upside down, Wait, is that going to fix the problem? Isn't Vulkan the special case the NDC is flipped compared to UV space? No. NDC, like normal, like we don't care about normal, like the normalized device coordinate in compute shaders, which is another benefit of doing this thing, is that it just goes out the window. But NDC in Vulkan is X to the right, Y down, and Z forward or backwards. I think it's Z backwards. Yeah, Z backwards. But yeah. I don't need to flip the. So if I flip the texture, then I don't need to do this reverse flip at all. So I just flip the texture, that solves the problem. Doing that is wrong. Sweet. So that would then mean when we load our textures in graphics, there's an STB image flip. True. To solve Vulkan's top left UV nonsense. There we go. No. One would. Right, so now that is something's still wrong. So we flip it. We just flipped the whole UV instead. Now. There we go. That'll do it. So now we just got to do it for this texture here. Save the picture inverted. Yeah. That's another way of doing it. That's true. Sweet, there we go. So, right. I'm not so glad that we had to do that, but I'm glad that we tested and fixed the problem because we would have just not noticed that for a while. So I'm glad we sorted that out. It weirded me out that J doesn't go as low as the Y. Where are you seeing that? When? Oh, in here, yeah. Yeah, weird. That really scrapes the bottom, doesn't it? It's probably because they had to do this, but you could have just moved this up. Or this centerpiece up by one. It's weird. Yeah. Sweet. Happy about that. So, what is the next thingy majig to do? Oh, we'll just move J down. Maybe. We've also got T as well. J's like an inverse T, right? Right. So what is next on the agenda? Is that complete? I wanted to monkey around with the test code for the this thing, right? I was playing around. Let's close this before we unsee too many other things. I wanted to move this up a bit. That was right, wasn't it? So just make sure. So this Y, we put it to about 2. It should move up. I smell fishy. It went down. Wait, sign. What's sign doing? Bottom left. Should be fine. 0 to 1. Times 0.5, so 0 to 5 plus. So 0 to 1, so that'd be 0.25 at most. Yeah. So then if we add 0.1, does that go down? It went down. Why is it going down? Yeah, I'm flipping the wrong thing, I think. So I've added the offset. So I thought I flipped the texture. No, we're not trying to rotate. We're trying to make sure that the UVs are correct. Put vertically on load. That's the logo. We flipped the logo. We flipped this one. Hey there, Coffee Lover. Thank you for the raid. Welcome, Raiders. How are you doing? Welcome to the stream. We're working on a game about an engine from scratch. We're currently doing some super crazy sign distance field based rendering. Yeah. So we're doing this completely using compute shaders, using a custom C compiler that I wrote. Welcome there, C code. And we're currently trying to make some super flexible UI rendering system. That means we can define some really sort of like cool UI by just defining some stuff on the CPU and you know, the GPU going crazy and rendering it. So currently it's we're just getting all the features in, and then we're going to do a full-on optimization pass on it. Yeah, if anyone's got any questions about any details, feel free to ask. Yeah, that's the real question, is the H upside down or not? I think it is. So let's change it to like a J, so we can all see the beautiful J. Why compute shaders? Oh, it was the right way up. So basically, like, we want to try and write a whole 3D game. So we're using Vulkan, right? And if anyone's used Vulkan, you realize that it's a complicated piece of work. You know, it allows you to do some really great things, but it's also like ridiculously complicated. So the idea is like, can we just use compute shaders, do a 2D and 3D rendering, and make a whole game? And what you realize is if you just use compute shaders, Vulkan becomes a lot more simple. So we've got a header file here with our GPU API, which is like our own OpenGL type of thing, right? Just allows us to launch compute shaders. It's about 250 lines of code. It's got a profiling thing in it. You can dispatch compute shaders. You can do synchronization. You can read back from buffers and textures. You can upload to buffers and textures, and you can create buffers and textures and samplers, right? So easy peasy. So the idea is like, can we make a very minimal like code base in terms of graphics? Because if you look at graphics programming, it's, if you want to do like something serious, do a serious game, it's like, yeah, you're looking at probably about 5,000 lines of code for a Vulkan backend, maybe another 2,000 lines of code for like a graphics front end or GPU API front end. And then for each backend, it's another like probably about, you know, could be 2,000 to 5,000 lines of code depending on the complexity of the graphics API underneath, right? These things get big. So the idea is like, can we do something very minimal and get something that looks beautiful and runs really great. So that's the plan. And also, you don't really have to deal with all the stuff that is in the traditional render pipeline. So you've got like the rasterization pipeline. There's a good picture of it, right, where you've got like all the stages, right? If you use compute shaders, you don't have to deal with this. You basically make your own version, right? So you don't have to deal with like understanding all of this, and even like transforming to like normalized device coordinates and all of that jazz, right? But yeah. Yeah, I wrote my own C compiler. So it compiles to SPIR-V. It's called HCC. It's open source. Yeah, it's pretty decent. This is the first project we're actually using it, and we've written like 5 or 6 samples, basically. But yeah. So why is it going down in the texture? Is there something wrong with this? Thank you, Coffee Love. Appreciate it. Why is the UV going? So flip the texture. The UV offset. Oh, another really cool thing is we actually have printf in shaders as well, so we can like print. We can basically like print. I don't know, but yeah, we can print stuff. Something like this. I don't know how you get printf to work in shaders, because I'm a wizard. Yeah, per warp. No, prints per pixel. I was asking earlier in the chat. I was asking that earlier in my chat. I was in Vulkan as well, fair play. Because if it's 12 vertices and you print out from the vertex shader, when it print 12 per frame, yeah. But also, there's like, you know, millions of pixels on the screen, so you print millions per frame. But yeah, we've basically filled up a buffer, and if it overflows, we don't print anymore. Yeah, I love how you thought about the vertex shaders. Like 12 is a lot. Sully, pixel shaders, they cover the whole screen. Imagine that. But yeah, as you can tell, it runs bloody slow when we print. But you know, you get your data. So yeah, you know, it has its uses, right? You have to like put if statements in if you really want to get good results. But we should maybe have a way to like basically upload like a little mouse coordinate so you can hover over it and do something good like that. That would be super ideal. Yeah, so you can actually see your values at least. But yeah, it would be super ideal for that mouse coordinate thing. I've got to find a way if I can do that well. We might just have like a common buffer where we just upload like frame constants or something. You know, that's passed, and we've got to pass it into every shader or something. But yeah, I haven't really needed it just yet. But it's one of those things where it's like if it's there, I'll probably use it more. But yeah, one of them. So could be doable with synchronization compute buffer. Yeah, I've got a bunch of like buffers and stuff. Yeah, I can just make another buffer. Like we have like these we use push constants, right? And I can just add another one which has like all of them, just a data structure shared between CPU and GPU, and I can just put the mouse coordinates in there. And so long as you're in pixel space, you can just do that. You gotta be in pixel space still. But yeah, I can just add another buffer of like, constants, and it's just a massive structure of all the constants in. But yeah, I'll figure that one out. So why the hell is my UV a bit buggered? What is going on? So if we add a UV offset, so that's the thing, it's like, so we can use it here, right? Is this thing ever negative? That is the question. If that is, or that is, then print it for me, please, right? What will the game be about? Yet to decide. So we definitely don't hit that. If that would have been triggered. Yeah, we want to like do a graphics R&D first, figure out the design, figure out the graphics art style, and then we'll sort of like use that as input to deciding what the game is. Because I feel like if I decide on what the game is right now, I'll get bored of the idea, or the idea will become very low resolution again, and then I have to think about it and it's changed. I'd rather sort of like, switch hats accordingly, right? So that sort of thing. But yeah. Right, so the UV offset is positive. We flip the UV after we have obviously made it, which is pretty good. So the problem is, like, as we increase this, oh wait. Coordinate, my friend. Are you top left? What is coordinate? Dispatch index. You would just be whatever we say you are, right? So, wait a minute. Have I declared this whole thing in top left? Ah, I thought in top left, didn't I? Damn this. I thought... Yeah, the whole thing is, needs to be flipped upside down. This is all wrong. It started at the top left, didn't it? So it needs to start at the bottom left. Aha, answers. So it was probably going the right way. So we flipped the whole thing upside down. How do we do that? Hey, Sockham. How you doing? Map compiles with the validation layer is active and it doesn't segfault. Oh yeah. It's going good, man. It's going super duper. Yeah, we've ticked off a lot today. We've done subtraction, intersection, rounded expand, outline, smooth union, smooth subtract, smooth intersection, texturing, glyphs. We're kind of in the middle of these actually. We've kind of discovered issues, but I think we're right at the end now. Gonna do some gradient in a second. But yes, looking good. Super happy with it. So we've got all these fancy things going on. Yeah, all C shaders. Got texturing. See here, there's like a border being applied and a texture at the same time. Made from multiple shapes and everything. Yeah, it's all stellar. It's all pretty good times as well, and I haven't optimized it yet. But we want to do a really good, chuck loads of UI on it. Let's see what we can do. So the coordinate is flipped, right? y. So when we define the... Right, so when we define these shapes, right, this is the top left one, but it really should be bottom left. When we define this, they're just numbers that go in, right? They're just numbers. And then when they come into here, again, this is just a number that we get. So it's not got any sort of orient. So where's the bit where we sort of like say, it's when we write out to the texture, isn't it? That's what it is. When we write this out to the texture. So the texture's like got a coordinate, and that's obviously top left because Vulkan. So luckily we got ourselves an output dimensions. So we can just say equals BC output dims dot y take. See, I love it when things are just numbers, but come on. There we go. Right, so now I've got to flip things upside down again. So I might not need to flip the UV anymore. Is that right? Because we flipped the UV. There's so many... Why can't we just all agree on bottom left? You have to figure out the perfect place to flip, but that would be more performant if we could do that. What am I seeing right now? Now the UV's wrong? No, you have to flip it. You have to flip it. When you do the sample. So if you have the bottom left, you got to take away to go up. Sorry, you got to add to go up. Sorry, wait, what am I saying? So you got bottom left. You flip the UV. So why is this upside down now? Right, these are all fine. Right, they're just all fine. No biggie there. Because they were just positional spaces on the screen and we flipped it, so that's good now. Nah, top left is much more intuitive. What? It looks like the Incredible Hulk, that's what it does. That's the color themes. Are you a graphics programmer in your job, or are you doing this to keep sane because you do back-end or similar? No, I will be doing this anyway because I'm quite interested by it all, but so I do graphics programming in my day job. I work in the games industry, right? But that's why I know so much about graphics, really, just because I do it every day now. But I kind of like game development as a whole, and I don't get to do everything. So I'm doing graphics first because it's the most complicated system that I want to try and make the most simplest first, right? For this project. And it helps define the look and the feel of what this project is going to be and gives us the capabilities. And then the rest is obviously stuff I really want to do still, but yeah. So bottom left is like a graph, my friends. You know, if you go into 3D world, you know, do you think you go down the stairs when you go up? Like, do you think you know, when you go upstairs, does the number decrease? You know, like it's top left is only intuitive because that's the way you probably learnt it. But bottom left makes a lot more sense. Like to have it all consistent the same way. Z up. It's just a letter though. Just a letter. I swear you're just trolling. What's the music? This one is apparently just relaxing or on water drops. I have no idea. I was just listening to a bit of wait, I should get the time code. Similar to that. Right. So why is my glyph flipped? Right. Wait, so is the yeah, the texture's flipped as well. So that's because we flipped the texture, wasn't it? Wait, but we want to flip the texture. What is left? Right, so we don't flip the texture and then flip the bottom left. Ah, my days. Why are things harder than they need to be? Okay. So if you have in the graphics system, what happens if we don't do this? Don't flip the texture on load. Well, it still don't work. Oh, wait. Excuse me. Did that wrong? Before we calculate the UV. That's what I meant. Right, that's not right. And that will still be wrong, right? Yup. Oh shoot, I thought I removed that. UV. Right, so we remove that, it will be wrong, right? And then we move this back to bottom left. No. I'm flipping the UVs too many times. You think? Or do I even need to flip it? So Right, so where do I need to flip the chords now? So I flip the whole screen upside down. Stores the pixels back. Yeah, too many flips. So, oh my days. So you got this. So, right, let's try and solve it from a vanilla thing. So, right now, we're trying to render J. J gets rendered. Great. So the problem is you just need to flip the little local thing that you've got. So we have the UV box. We just got to flip the box. So we have the bottom left and the size. So if we flip, so size will be multiplied by there. That's the offset. So size is fine. So you want to you flip the box. So you push the bottom left up to top left. No. No, you flip the UV offset. Which means you just flip UV size the other. local space, that's unorm. Sweet. So we flip this one. Dot y equal 1 take that. Okay. So we apply that here as well. Boom. Right, I think that's it now. So let's comment that quickly and just say, right, so we don't flip the texture anymore because the screen is flipped on right. Okay. Well, 1.f. .f is just a float literal. Otherwise, it's a double. So it's just an F32 rather than an F64. Flip to top left. Flip because Vulkan is top left. Vulkan UV space. Something like that. Right. So now let's have a bit of a play with that thing we was doing with the search for glyph. Right. So we want to have a bit of a play. So I want to, if I up the Y number, this should be more visible at the top. Right, if it goes up. So put a 3 there. It went down again, guys. So it's still wrong in another way. So am I flipping the wrong thing then? Yeah, spaces. Oh no. Oh, damn it. So it's going the right way. Maybe. So there's an offset here that you get from offset screen space, then there's offset local space. Right. And then that gets you your UV and your pixel color. Your pixel is then... So as you increase your... Right, so as we increase the bottom left number, that's moving it down. So we are flipping the wrong thing. What should we be flipping then? So the UV needs to be taken away. Needs to be... So as if you need to like subtract the Y. And then flip the Y. This doesn't feel too right. Right, let's go back to step 1. So you go to write this pixel here, right? And this one, right, so you have this sort of like coordinate here in pixel space, like from bottom left to say, right? And then, so we want to try and calculate the UV of that, which would be basically the top left of this J box. So you get your offset from the bottom left. So here's the bottom left. You get the offset, so it gives you like 15 pixels or whatever it is. Or it gives you the pixels in screen space. So whatever that is in screen space. Then you do your divide by the dimensions of the box. And the box is, say, or whatever, right? So it gives you like, basically gives you like 1, right? It's normalized from 0 to 1. Then you multiply by the size of the UV. So imagine this is just one big texture. So for the sake of whatever, so that'll be 1 on the Y as well, right up. The size would just be 1. So that's good. So then that gives you 1 at the top. Then this one is saying, right, the bottom left UV, so it'd be 0 in this case. This is not really good, I guess. Add 1 will give me, obviously, 1. Now, that's going to be the bottom, because it's top left origin, so it's kind of wrong, so you got to flip it. But you don't just flip this one, because that's the whole wrong coordinate. You need to flip, right. So I think we need to comprise UV of something like this. UV.x plus offset.x. Then it'll be UV take Y. And then your bottom left. Wait a minute. Offset, local space, UV space. So we flipped the local space before on the... We flipped this from 1. So we did like a 1. Something like that. Let's try that out. See if it fixes the problem. But I don't know if that's the solution we want. Right, that didn't do anything. Wait a minute, it should just be take away. Sorry. Allow. Right, so that got me Z. Good thing. So Z is the next one below, right? J, Z. Okay. So the cell. So if we're taking away, you've gone the other way. So maybe, oh, yeah, we've done that plus 1 take that before, right? And that didn't work. For, oh, come on. Wait, that just does a plus, doesn't it? No, sorry, that's just invert. What did we do before? We flipped. Oh, no, sorry, we meant to flip local space, wasn't it? Right, so we did a takeaway. I think then we did like a offset. I want to take that. Wait, before we calculate the offset UV. Now the Z is flipped along the X? What is going on? Right, let's go back to that drawing board again. But this time, let's use something more complicated. Sorry, something... Too many flips. Oh my days. Right, so flip the whole screen writes back. Flipped. Which is fine for everything because it all works off screen space pixels, but the textures are a bit off. So it's all because this thing needs to sample from top left. So, right. So, rightio. So we take for instance this point up here. We get the so we have that in pixel space, that point top left, with this bottom left A, B, B position in pixel space. We take the difference, so we've got an offset. So we're like a vector going up to there. Then we divide this by the dimensions. So we get basically 1 at the top. Now, we have this thing called a UV size. So this is the size of this thing in UV space. So it's 1 divided by 16. Right, so let's just say that's 1 divided by... So whatever 1 divided by 16 is. Right, so 0.065. So now we have that offset, okay? Right, maybe we flip it here based on UV size dot Y. Yeah, maybe you say offset equals UV size dot Y, take away. Yeah, but then I'm just flipping it in the same. Like flipping it before then flipping after shouldn't have changed. Much, right? Alright, that did flip it, but then does the offset, it's the same issue again with the offset, right? If I, so let's put this back to 0.1. Okay. If I add, it adds another little bit. The thing moved down. So there's something with this bottom left. So it's a little bit too early if it's there. So, but after you add that bottom left, what we need to do is we need to Yes, the UV is... So we have to do it after this has been... So if we flip this value on the Y, then it means the Y will go in the right direction. When it's increased. Right, let's recarry on what we had going. So this is like 0.265 the offset, and then we got like... So we've got this bottom left value here. So let's get a real number. So we got like J. That was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15. Good, so it's 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 10 by 9. Wait, all we needed was the top one anyway. So 1 divided by 16 times 9 gets you 0.565. So right. So we add that number to it. So we're up here. Bottom left, we add the number up there. Shoot, where is it? Flip floppy, yeah, it's too much flipping. It's flipping crazy, this thing. So our UV bottom left is saying that it is like a Y of this number. But it needs to be top left. Yeah, that number. And say with the top left pixel, right? So we add that 0.0625. So that would up this number to about 0.6. Which would then move it down. Oh, rotate my mono, perfect. Yeah, that'd be a good idea. Man, definitely getting tired. Too much thinking today. So close though, you know. So the problem is, if you flip this, you've got to flip the whole texture space as well. But then you want to be... See, I think let's work with the... Let's just do it on the glyph code. Because it's the easiest one to work with. Because that gets you the wrong character. But then if you flip the texture as well... Where's the damn thing? There we go. So flip the whole texture on load. So the pixel's the other way around. You've got Z. Well, we're pretty close now. Yeah, but then... so you got this Z here. But we want to have the J, so it's got to be like one down. So then it should be like maybe that minus right. I think that's done it. So let's have a little monkey around with a number. Hopefully it's still fine. Glyph. I'm not sure when you was last TMTG. But yeah, we've just been trying to do this texture space thing. It's been bloody annoying. We've been getting this correct. Like the... So we had to flip it upside down. So origin is bottom left, because we kind of forgot. And then what ended up happening is the UVs were wrong. Let's sort those out. Time to reverse the screen chords. Yes, the UV coordinates was wrong for the glyph and for the texturing. So we've had to, like, we want to increase, as we increase Y, I want it to go up. So I think we've got that working now. I think at least. So we up this by about 1, I don't know. It's gone up. I'm pretty sure that went up. Let's undo it. Yep, that's good. So bring it down a bit. Right, we did it, guys. Mission complete. Oh, my brain. Too much thinking. Bring that down by 0.2, that's what I meant. Or 0.1 will do. Extra pixels. Cool. Oh, very good. Alright, stick a comment in there. Wait a minute. We didn't put it here. Oh my days. Is it still, it's still flipped in it, you bastard. You bastard. Let's move down again. Grr. Flipping coordinates, man. This is why I want to keep them to the bottom left. All the time, so I don't have to flip these pesky coordinates. So this is still kind of wrong. So that means you'd have to flip. So as you increase the offset, How does this J? But as you increase the J works, right? Because this is simply just that, meaning as you increase it, and it's bottom left origin. Right, and that one goes up just fine. No, I'm just doing a basic image, just bitmap for now. We'll probably use FreeType later, or SDB TrueType, one of those two. So we flip this. Does this set something so it's always on? Yup. Just double check it doesn't fudge something. We do it twice. No, it's fine. Yeah. So this glyph here, it works. So you increase. Hang on a minute. So this glyph here, as you increase the bottom left, it will go. Let's up this by like 0.1. Wait, glyph is 0.06. So if you say 0.01, something like that. Point F. It's probably flipped by default and should fix if you don't flip with STB. Yeah, so I flip it. Yeah, what do I do? I flip with STB, but when I write the... Yeah, it's something to do with the fact that the top left, like we want to use bottom left UVs, but this is top left UVs, and the screen is flipped as well at the end. I don't think that matters so much. The problem is mainly just flipping these. Yeah, that should be it, right? That's the main problem. I just got to flip the box. So right. Yeah, so you just got to flip the boxes all. Right. So that's your bottom left. Yeah, that's not probably too hard, right? So you just make a new UV. Dot x plus. So this one is offset UV dot x. Right, I think we got it. I was thinking about it more complicated than it probably was, I think. UV bottom left or white. So you're flipping. Flipping them. So So if you place this up at the top, place it at the top, and then take away the offset instead. I think that's what was missing. Maybe not. X should be 0, 1, and Y should be -1 if you double flip. I'm not sure if I get... So you put the... There's just an add to add the offset. So you put it to the top of the box, take away... What glyph did we get? So we're trying to get the J, and we got the U upside down, which means we don't need the flip anymore. Right. I think that's it. Right, let's try that one out. So we just need to flip the box. No flipping of the texture. Oh my days. Right, let's try this one out. Let's try these chords. You take the max X, subtract the X, max Y, subtract the Y, don't you get... Bananas, pure bananas. Max X, subtract X. Yeah, I don't want to flip the X though. I just want to flip the Y. It's the Y that's the problem. So we've put it up to the top and then subtracted it, so we've sort of done it the other way around. Yeah, just the Y. So, wait, what we're trying to, what's the next thing we're doing? Oh, you want to have a bit of play around with the texture. So, let's go to the glyph code. Right, so texture. I still think it's a bit, it's still the wrong way around. This is the bottom left code. So bottom left UV. As we increase this, we should be going up in the UV space. So all I'm doing is just adding an offset. And it should be going up, but it's not. So this, when I increase this number, it should be going up the UV, and this scrolling down. If I increase it by 2, and it goes the other way around, it scrolls up instead of down. So the UV's moved downwards. So I was hoping that would have fixed it, but it kind of didn't. Right, because maybe I meant to flip the UV. No? Yeah, this has to get flipped in some way then. Yeah, I'm not sure because this is to do with Vulkan, but I know, but actually you did top left, isn't it? So maybe it does work. I'm not sure what you're saying there, MTG. Yeah, origin is lower left. Going to top left. And for some reason my brain is fried and I can't figure it out. But it's like as I increase the bottom left offset, it's like I want to flip. Like it should be going the other way. So it's like as if we need to say one take somewhere. It has to be a one take somewhere to get that to go the other way. But then when you do that, you need the texture flipped. Right. There must be a simpler way. When you do that, you need the texture flip because you've flipped your UV. Right. Um, um, and then yeah, that's right. So if we just do that alone, maybe then take that. I think there's something to do with the rectangle that's got to be in there as well. Let's try and get this J to work again. Right, so that's buggered. Wait. That's flipped. But I enable flipping there. Okay, so they use the right way around. Wait. Okay, so need the rectangle size in there to flip the offset the other way around. Wait, or is it just a plus? That gets you the Z. So minus gets you the U. Oh, an upside down J, right. So you basically want to invert. If that's an upside down J, it's that take. Right. So that's the right way around now. So a lot of silliness there. So then if I put this up here, I could have sworn there must be a simpler way of doing this, but oh my days. Okay. There must be a way to do this without flipping the texture. Right, so we set this at origin 0, 0. So this texture is in the middle. So as I increase this number, it should scroll down. Right, like this bottom left should move up. Therefore scrolling the texture downward. Right. Because it's the UV. Right, so say 2. Still the wrong bloody way. Unless something to do with this is wrong, right? Come on. Let's hard code it instead. Maybe I should have done this all along rather than a complicated thing. So if we increase this number by to 2, that should have moved. Right, let's put it back to 0 again. Right, so it's here. This is the center apparently. So we should be seeing it scroll. Can we just remap the texture to make them bottom left orient? I was meant to set the wrong size and it cost me a lot of time and energy. Damn. I feel you. I think we're doing something dumb like this right now. I can feel it. It's just something really dumb's going on. There's a simple way. Can we just remap the texture to make them bottom left? Yeah, so we've flipped it. Right. We've flipped the texture. So that's how you do it, right? You usually flip it. But is something else wrong? So I increased this to 0.2. How did this move? So it moved as if like... Yeah, the UV went down. Yeah. Like you can tell it's wrong. If you put 0 on the Y, bottom left, like that's not the bottom left. Right, the bottom left should be, like it's just wrong. It's not in the right place. Unless I've done something really dumb. No, sensible. Texture sampler bottom left, 2 words, yep. So if you flip the texture, so let's just undo some of the code, right? Right, so let's just leave that there. So we flip the texture, and then let's just put the standard UV thing back. Add F32 times 2, which will be UV bottom left plus offset UV. And that's just on the text one. We haven't changed the glyph one around this time. So that appears to be right. Okay, so if I increase it. Was it something to do with that code there? Let's have a look. So if I increase this is the Y. If I increase that, it should just, the texture should go up a bit. Right, I think that worked. It went up. So why when I was using sine, didn't? So I had something more complicated here. What is going? I knew this thing felt more complicated than it needed to be. So if I put that back, does that still work on the glyph? Right, the glyph is still... Wait, where's the glyph wrong? That's like a U here. When you want the J. Oh my days. I just realized what I've been doing. So the problem is ugh, right. So this texture here is like, you know, it doesn't, it's just, we just need to flip the texture the other way around, right? And it's fine, and it works fine. But this glyph texture here, the way it's ordered is addressed is obviously from the top left. And I knew this, but then I thought for some reason I could just do it in the shader. But like, really what I should be doing is flipping, like the way I generate the UVs is wrong, basically. That's the whole thing. Damn it. So the thing is, this thing here needs to say like 15 take that, basically. So it needs to go, it needs to flip the way the UV is generated and not. There we go. That's it. So this is getting a glyph ID, which is basically like an index. It's like a glyph index that goes sort of like row, is it called row major, where you sort of do the row, each row at a time, right? So it's just mapping it into that, right? Index into a 2D coordinate. So the problem is the glyph ID starts up here. But because I've flipped the texture, it needs to be the other way around. Something like that. Oh my days. And then I thought I could just, then I really overcomplicated it in the shader code. Fixing it in the glyph one first, fixing the glyph one, then it was the other way around for the texture one, and that's where it was really confusing me, and it's sending me off the rails. Damn it. It always, this thing happens like every once in a while. Like I'm on fire for like, and then like get tripped up by the most basic thing. My days. These things. Yep. Right, so I'm glad we fixed that. Thank you for persevering, everyone, and giving me little things to sort of like bring me back to sanity. Thank you. Oh, that was good. We found it out. Right, so we can put that sign thing back, at least. So, the idea was it could like... Yeah, also, complicated code, thinking you could just change a number. And yeah, simple code when you're testing out problems. Like, damn it. Right, so I want to do something like... Let's just see how that looks. Right, so I want to move this down a bit. That's all I wanted to do. That's all I wanted to do. So if I take away -2, it'll bring it down. There we go. My days, I'm so dumb sometimes. But anyway, looks good, doesn't it? Looks good. So, good progress today. We got all this done. These two guys done. Right, textures and glyphs. Oh, so on the next stream, we want to get a nice gradient coloring done, right? We do gradients based on distance, gradients based on X coordinate, Y coordinate, right? Get some coloring that way, be proper cool. Then after that, we've got all the features that we want, kinda. So I want to try and anti-alias this. How do we do that? You know, so we get some nice aliasing on the little rounded corners, because right now it looks a bit janky, and you might not see it, but you might not have a tuned eye to it, but it definitely looks better even if you don't have a tuned eye to it. But yeah, as you can see, it's just really jagged. Yeah, it's one of those things where it's like subtle, but it definitely makes it look better. Yeah, radial versus directional. Yeah, I guess that's the way of saying it. Yeah, radial versus directional gradients. And then transforms, right? Next stream is transforms too. So you get rotation, scaling, and skewing. And then clipping. So we want to do some form of clipping where we like do some like sign distance fill clipping. So we're just adding more sign distance filled stuff, right? So it's like SDF with alpha, right? You can do distanced with distanced alpha, which would just be pretty insane. But you could do some fade outs on edges, basically. It's really powerful, but it's again, just adding more SDFs to the solution. I've got to commit these changes, which I'm going to hopefully fit in before I go to bed now. And then compile a Windows thing. Oh, so yeah, I'll commit this code up to the code base. So for those of you who have access to the code, you'll be able to download that in an hour or something. And it'll work on Windows and Linux. Yeah, amazing. Can you do anti-aliasing past the end of the frame? You will anti-alias the actual game anyway. Yes, the problem is like anti-aliasing is like when you do those post anti-aliasing, it's basically like you're gonna blur it. You're making a trade between blur and jaggedness, and those things are not perfect. So if you can do it in the shader and do it perfectly for that draw, it's going to look the best, basically. So on these shapes, we know what is a pixel and what is an edge, right? Whereas those algorithms have got to find the edges, and they're not the best at finding the edges. So even in 3D, if we can know what the edges of our thing that we're drawing, we've got perfect AA, right? So that's what we're going to try and do as well, is not have any of that AA stuff that games typically do, right? Like, so multi-sampled anti-aliasing is like the best, basically, because it gets it right. Cool. All right, thanks for coming, everyone. Well, next stream is on Tuesday, and I'll be 6:30 p.m. GMT. I would rate Eric the Wise, but he's not programming Game Boys today, unfortunately. But yeah, thank you so much. Appreciate you guys. Where is someone playing C? Thank you, thank you. Right, I cannot find a soul to raid. Oh wait, I found one. X86, we got it. Right, have a great start to your week, everyone. I'll see you all on Tuesday, if not Thursday, if not Sunday. Well, yeah. Thank you, thank you. Thank you, thank you. Right, much love, everyone. Catch you later. Bye-bye.